Good morning, good afternoon, and good evening, everybody. My name is Kartik. I'm one of the co-founders of ETH Global, and I'm super excited to welcome all of you to Scaling Ethereum. All of you are watching this on ethglobal.tv. For those of you who are joining us for the first time, this is the platform we'll be using for the rest of this month to host all of our talks, workshops, and summits. And you're in for an amazing time learning about everything that's happening in the world of scaling Ethereum. All right, let's get started. This hackathon is brought to you by ETH Global. ETH Global is an organization with a very simple mission. Our goal is to onboard thousands of developers into the Web3 ecosystem. And we do this by running two things, hackathons and summits. And scaling Ethereum is no different. We have an amazing next few weeks planned. We're going to host 3 summits, 2 of which I can talk about. The first one is a kickoff summit. You're going to learn about all the amazing things happening in the world of rollups right after we cover the hackathon logistics. Then on March 24th, the Friday, we're going to talk about what's happening in the world of MEV with the Flashbots Summit, and a super secret announcement coming in on March 27th, the Monday, a few days after the Flashbot Summits, about something that this entire ecosystem has been eagerly waiting for. We're going to release what those announcements are and what the summit and those speakers are very soon. So stay tuned for the next few weeks to learn about all the impressive progress we've made as an industry in the last couple of years. All of this will be on ethglobal.tv. And today we have a summit that's going to cover all the things that's going to set the theme for what everybody's doing to scale Ethereum. But the next 30 minutes are about the hackathon. We have so much going on for this event, and I want to make sure we take the time to talk about everything that we're going to do to structure the next few weeks for you as hackers, and for those of you who are joining us for the first time, tell you how everything works. And for those of you who are coming back, welcome back, and stay tuned for a few changes we've made to our previous formats. So this is already an impressive and massive event. We have over 1,200 people from 89 different countries participating in working on projects related to scaling Ethereum and building on L2s. And they are from 24 time zones. We finally managed to cover all time zones. And I can't wait to meet all of you here and see what everybody's excited about. I also put everybody on a map to see where everybody was coming from. And it just continues to blow us away because we have representation from 6 continents and so many cities around the world. The last time we counted this a few days ago, that number was closer to 500 unique cities. So that's awesome to see, and welcome everybody. And thank you for staying up or staying late, early, everything from all these time zones. We really appreciate this. Not only just that, we have 107 mentors who are going to be here helping you over the next 3 weeks to make sure that your project comes to life. And 19 amazing partners that are giving out help, guidance, prizes, and mentorship to make sure that you succeed in building on top of Ethereum and layer 2s. And they're also going to be giving out over $200,000 worth of prizes. So there's a lot of prizes that we can do, and we will be doing and talking about. So not only can you learn everything that's happening in this world, you also get to win some amazing amount of prizes for building interesting and useful things. I want to give a quick shout out to some of our amazing partners. We have Optimism, Polygon, Scroll, Gnosis Chain, Ethereum Foundation, Filecoin Virtual Machine, Hyperlane, ApeCoin, Fuel, UMA, Connects, Polybase, PSC, The Graph, IntMax, ZK Era, Mantle, Tyco, and Push Protocol. All these companies and our partners are here with us for this entire month, helping out, talking to all of you, telling you about how you can simplify your life by using a lot of these SDKs and not reinventing the wheel, and also giving out a lot of prizes. But enough of that. Let's talk about some of the stuff that you all need to know, specifically about the hackathon logistics. The most common question we've gotten is, what can I build? There's a lot of you who are joining us for the first time. There's a lot of you who are seasoned engineers in big companies that are trying to understand what's possible in crypto. And some of the themes that we think are going to be very helpful for you, and also what others have said they're going to do, is on this slide. People are very excited to play with different DeFi primitives and DAOs and NFTs on different L2s. So you get to take advantage of a lot of the scalability benefits and low gas costs for making those types of transactions. And you can do a lot more interesting stuff, or a lot more stuff that can be corrected on chain if something requires higher transaction amounts, not from a dollar standpoint, but just from the number of edits or commits needed to get to any outcome. We have a lot of support for building on ZK rollups. There's a lot of things you can do in terms of understanding how we can add anywhere from privacy to some more guarantees to just hiding some information that should be not needed or must be publicly available for somebody to act on. And you have a lot of support for doing this for anywhere from account abstraction to DeFi to NFTs to simply making just better tooling for the next wave of people to do all these things more efficiently and faster. Of course, the reason why we're doing this event for the second time is because we feel like the Layer 2 ecosystem is still lacking really, really good developer tools. And we want to really get thousands of more people to build on top of these scaling solutions. And even if you can't find an app, or you realize that something was really hard as you were doing your app, you get to take some time and make a tool that makes it easier for yourself and somebody else, and let them make applications on top of these solutions better, faster, and more quickly. And of course, it's okay to not work on an app. There's so much to do here in this entire ecosystem that you can also take the time to build some guides or documentation, or simply clarify how somebody can use it and help educate everybody else on how they can be in this ecosystem faster, quicker, or just really get into some of the nuances that everybody needs to know to build on top of any of these solutions. If you are one of the teams who's working on making easy to understand how to do something or how something works, you also have the option to submit those guides to ETH Global Guides. We'll be more than happy to publish one of these guides here. And if you do end up writing something that can help thousands of people, we'd love to make that an official guide on ethglobal.com/guides. All right. Now let's talk about the next 3 weeks and how all the logistics is set up for everything. I'm going to cover what you can do to find a team member, how you can get any help, all the prizes, of course. We're going to talk about all of our summits, and I'm going to talk about the most important thing, which is how judging and project submission is set up. So the most important thing is communication. So let's dive in. Everything is going to be on Discord. That means if you are a confirmed hacker, you would have seen a connect Discord button on your hacker dashboard on ethglobal.com, and you should be able to see a Scaling Ethereum section appear on your Discord sidebar. That means that only people who are participating at the hackathon are going to be able to see those channels. So really make sure that you see that and you are actively connected to Discord, because that's where all the announcements, talks, prizes, help, all that will be managed there, including talking to all of our mentors. And these are private channels, which means that if you're not part of the hackathon, you will not be able to get access to them. And it helps us understand how do we make sure we effectively communicate things precisely to everybody who should hear about those announcements. And that's also where all of our partner channels are, which means if you're working on any of the protocols out there, whether it's on an optimistic rollup or a ZK rollup or some dev tool or some dApp or any push notification service, you can message anybody on that team through those channels. So please make sure you're connected to Slack, and also make sure that your team members are there, because you also get to talk to each other there. And that's where you can just make sure you can ping anybody, including the global team and our partners and our mentors and all the other hackers too. On top of that, we'll also be sending out calendar invites for all talks and workshops. You would have seen a calendar invite today for this very session. There's a handful of other talks and workshops happening. Some of them already happened yesterday. We have a lot more next week. All that is going to be notified to you on your calendar, so it normalizes itself for the different time zones everybody's in. And as a note, all of this is meant to be very asynchronous, which means that we try our best to do things multiple times over the course of the hackathon and repeat this so we can optimize for multiple time zone overlaps. But even if you have other obligations, whether it's school or work or something else, everything is going to be recorded. So even if you miss something, it'll be available on youtube.com/ethglobal immediately after it ends. and we make sure that everybody can catch up and watch things at their own pace or their own speed limit and really understand what's going on and not miss out anything. And to see what's happening, everything is going to be on our website, and you can just head over to ethglobal.com/scaling. There you'll see the full schedule. If anything changes, you'll see that reflected there. What's on the website is going to be the source of truth. So we make sure that everything, whether it's your calendar invites, whether it's the talk titles, whether it's a 5-minute delay, all of that is reflected properly on our hackathon website. So the most other common question we've gotten is, how does this hackathon work? For those of you joining us for the first time, it is fairly straightforward. The hackathon officially begins now, and you can start working on your projects. You can work with them with a team, and you can have a team of up to 5 members. And you have the next 2.5 weeks to hack. That means that whole thing is about 3 weeks long as an event. That includes some of the extra time we have for judging and doing the closing ceremonies and going through all the prize winners. But you have the next little while to talk about all these things and work on our projects. So I'm going to spend a bit more time here on all the things that matter here for project submission and other things that you need to know. So the rules and criteria is the most important thing. Everything that you're doing must start today and must be done from scratch, which means that you cannot work on a pre-existing project. You cannot add features to something you've done, and you also cannot just deploy something you've done in the past to some layer 2 and call that a valid submission. On top of that, only people who have successfully RSVP'd are eligible to win prizes, which means that if you're working on a team of 5 and 3 of the people are listed as your team members at the point of submission and the other 2 were accepted but didn't RSVP properly or didn't join your team, if you win a prize in this situation, only those 3 people will receive the prizes, not all 5. So please, please, please make sure that all of your team members are RSVP'd and listed and confirmed on your hacker dashboard. And also, there's going to be a lot of edge cases, and we totally understand that. So if you have a situation where you want to clarify something, you can just message us on Discord or email or direct message or Twitter, whatever it is. We'll be able to understand what your unique situation is and help clarify and address any issues. So don't hesitate to ping us. And if you have anything that comes up, you can let us know, and we'll be able to get to it immediately. Next, and the most important piece is judging. So here is something that we're changing for those of you who've joined us in the past. Submissions are due on Sunday, March 26th at noon Eastern time. Everything we're going to do is default to Eastern time, which is Eastern time New York. And you have until March 26th to work on your projects. After that, we'll kind of talk about how judging works. But what it means on that Sunday is you will have to create a 4-minute demo video to submit what you've worked on over the past few weeks. This 4-minute is what's going to be a snapshot of what you've done and what everybody will look at to review your submission for any prizes or any comments. This video is required. This video is also very strict on the time, so you cannot go over. The dashboard will automatically prevent you from submitting something that's longer than 4 minutes. And we also review all these videos individually to make sure that everything is as part of the rules. So if you speed it up, that also gets you disqualified. If you try to make it too long, you'll just be stuck on being able to submit your project. And if it's too short, that also helps you not convey what you built on properly. So please make sure that it's appropriately and as close to 4 minutes as possible to really enlighten everybody on what you worked on for the past few weeks. And please, 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 please don't prepare this last minute. We see everybody realize that they need more time to make it better, to make the demos work really well, to sometimes focus on conveying the right messaging. All that takes time. We recommend you block at least 2 hours to do this. Even though it's 4 minutes, it will take you a few revisions to get things right or make sure that everything's under the time limit. And all these details are going to be on your dashboard. Right now, you're only going to be able to see how to create a project, but next week onwards, you'll be able to see all the specific things that you need to do to submit your project and how the video works, and some previous good videos that we recommend using as a reference for what a great submission looks like. All those things are going to be made visible to you on your Hacker dashboard very soon. Now let's talk about what's changing for judging and how everything is going to be set up after you submit your project. We have two tracks of judging. The first one is main judging, which helps you become a finalist for this hackathon. And the other one is a partner prize judging, which is only if you are interested in submitting for a prize, but not anything else. For those of you who've been part of our events before, the format's the same, but we're adding an additional step moving forward. So I'm going to talk about what the main judging looks like and how it's going to work. It's going to be set up in 2 rounds. And this is how the first round looks like. When you submit your project on Sunday, the next day is when we're going to do round 1 of judging, which means that instead of joining a live call, which is how things were done before, there will be a asynchronous round with our judges who will review your video submissions. And we'll also be checking anywhere from your Git history to the quality of what you submitted to the live demo links that you published to everything around your submission and qualifying you for the next round for the live demos that you are used to. This means that not every project will move on, even if you wanted to be part of the finalist track. And within 24 hours of submission, our goal is to notify the teams that are moving on to the next round to default to a live demo to our judges, where they get to have a conversation and talk about what they built. So as our judges look at all the submissions on that Monday, we'll be notifying the teams that made it to the next round. And that judging happens on Tuesday for round 2. The way round 2 is set up is fairly straightforward. All those teams will be sent a Zoom link. You will then be able to go on that call and simply demo what you built. You will still get 4 minutes, and we default to playing the video that you submitted to our judges. It'll be a different set of judges as well. And in addition to the demo, you'll also then get a few minutes for a Q&A. After that is what we'll have to determine who our finalists are. And that's what sets up for the closing ceremonies, where we're going to demo some of our top teams to share what they built and what they were excited about as some of these teams. So the Zoom call will be synchronous, and this will happen from 12 p.m. to 2:30 p.m. Eastern time. And this will allow all of us to be on the call synchronously and chat about everything that you're excited about, everything you built, or any questions our judges have about your submission. So that's the net difference. We'll notify this again to everybody over email, and all this information will also be available on your Hacker dashboard as soon as submission opens in about 10 days. And then for those of you who are not interested in the finalist track and want to just go for partner prizes, that remains the same as before, which is the partners will look at your 4-minute video and your source code and your live demos and the project description to determine what is the best team that represents the values that they're trying to accomplish for that prize. They will look at this at their own pace asynchronously and contact you on Discord or email if they have any questions. So this means that as long as you specify during your submission process that you are trying to go for X prize, the partners will be notified that you are one of the teams and this is your submission, and they'll be able to look at this, and over the same window before the closing ceremony, they'll be able to tell all of us who the winners are for their projects. This also means that if you forget to notify in your submission process that you wanted to go for X or some specific prize, then we have no way of knowing that this is what you wanted. So please make sure that you select the actual prize you are trying to qualify for. Otherwise, we won't be notified, the partners won't be notified. And if you say, how come I didn't get this prize, or how come someone else was chosen over me, it means that nobody had the information that you wanted to be part of that prize. So you'll get to do all of that through your dashboard, and all that will be available to you very soon. But in summary, you have to make sure that you take the time and make the video good. That is the best advice we can give you, which is that 4 minutes represents 3 weeks of work. and making sure you get the time to highlight why you're doing this thing, who you are, why it matters, and why you're excited about it is going to be very critical. That video is what determines you receiving a prize, you going to round 2 of judging, and also being a finalist for this global event. So make sure you take the time and don't ignore the work you need to do to make your submission look amazing. And of course, I don't want this to be intimidating to all of you. The biggest question is, well, what if I'm new to all of this? Well, not to worry. This event is designed for a lot of beginners, and our goal is to make sure that we do everything we can to make it really easy for everybody to understand what's going on and really take the time to learn and use the next few weeks instead of just a hackathon weekend to make this useful and knowledgeable and a good learning experience for them. So a lot of content for beginners and experts. No matter what your skill set is, you have things to catch up on here, and you can watch those talks. You can watch historical talks on our YouTube or learn about any protocol that's out there in this space and get a guided tutorial or even talk to the people who built it directly. So a lot of these talks and workshops are available. If you want to just understand what's happening thematically, that's where the summits come in. We're going to start off with our first summit in 20 minutes. And our goal is to tell you at a high level all these things that you're excited about, whether it's how optimistic rollouts work, how ZK rollouts work, or if you saw the announcement about Coinbase's new OP chain base. All that will be told to you on why these things are excited very soon. And there's a massive set of guides and resources available to you in your info center. It shows up now on your nav bar on the hackathon website. You will see that link on your calendar invites too. You can see everything from the rules to criteria to submission guidelines to a list of previous submissions that we think are really well presented. All that stuff is available to you to read up on immediately. And you can just go there by clicking on the info center link. And of course, if you have any questions, this is a live stream. I can see all the questions on the global.tv chat, so just ask away at your questions, and we'll be able to answer them. One common question we've already gotten is, do I have to decide between the main judging track or the partner prize track? The answer is yes on just the main judging track, which means that if you pick the main judging track, you are still qualifying for the partner prizes. It's just that if you only pick the partner prize track, that means that you cannot come back and qualify for any of the main judging finalist prize tracks. So no matter what you choose, you are still going to be looked at for all the partner prizes, and we'll make sure we make that way more obvious as well. But you are not going to have to make a decision between do I want a partner prize or not. All cases you qualify for that. And last thing is everything is on our YouTube. So of course, there's a lot of you who are not sure what you want to build yet, or you're not confident that what you have will be accomplishable in the next few weeks, or maybe you need help on specific skill sets. We got you covered. All that stuff is also part of the plan, which is the reason why these events are multi-weeks, is because you really get to learn and then try it out and see how to do these things. So there's a Find a Team channel on your Discord. There you can see a couple hundred people who are also in a similar position as you, where they're looking for somebody with specific skill sets or just want to pair up with somebody. And you get to meet new people from across the world. You get to meet really, really smart people who are excited about what's happening in Web3 and work together on a project over the next few weeks and really accomplish something amazing. And of course, because there's so many of you from literally all time zones and close to 500 cities around the world, we want to know who you are, why you're excited about this thing, and what you really are passionate about. So go to the Scaling 2023 chat channel and talk to all of us. Say hi to ETH Global members, say hi to everybody else participating, and we'd love to understand how you got into this space. And of course, it's also possible to hack solo. You don't need to have a team. It's just easier if you have somebody also working with you, because you then don't have to do everything yourself. So if you want to do something on your own, that is also totally fine. You can submit something individually, but if you are trying to work with somebody and reduce the workload or just get complementary skill sets involved, you get to do that with a team. And there's also now a tool on your dashboard to help find team members. This is a double opt-in tool only, which means that on your dashboard, if you set that you need help, or you're looking for a team member, then the second you check this off, you'll be available on this tool, and other members can find you based on the things that you can do for a team, whether it's front-end development, design, back-end development, Solidity development, all that stuff. You can specify and find other potential team members who have those skills or the skills that you have that you like to contribute to another team. Now let's talk about check-ins. This is going to be very important. Our goal is to make sure that you can understand what's happening in this space, especially from so much information that exists out on the internet. And to help simplify that process and make the best use of your next few weeks, we implement something called a check-in. A check-in is a simple form, for lack of a better analogy, a quick survey or a stand-up update that happens on a dashboard, and you just get to tell us how things are going. If you finally have an idea that you're excited about, if you're stuck on something, if you try to get an answer to something about an SDK and you didn't hear back, or you couldn't get the right person to answer your technical question, or you're stuck on this bug and it's just really stopping you from moving forward, all these things is what we use the check-ins for. And from that, we get to route and triage you to the best person who will be able to help, or just simply help you ourselves. We're excited about building on Ethereum. We're excited about ZK technologies. We're excited about optimistic rollups, and we want to get people to build really, really cool things. And these check-ins help us get you to where you want. Also, the check-ins are a big piece for getting to the submission piece. So you do have to fill out these check-ins just so we know how things are going, what we can do better as ETH Global. So all this will happen via your dashboard. It's a really quick form. It should take you no more than 10 minutes. And anybody on your team can fill this out next week and the two after. The way we kind of think about this thing is that as you're thinking about your projects, you should break down the work into these equally adjusted timelines. You should take the first few days of next week to really brainstorm what could be possible, understand some of the stuff that is possible or not possible with different technologies, watch a handful of workshops and talks, and talk to a lot of our mentors and see, hey, I'm trying to do X. Does this make sense? Or is there a better way to do this thing? Or is this a more efficient way of doing something? And as you kind of gather all of that interest, use the week after to really build something that you want to submit and get people to test it out, get people to give you feedback. And then as you learn through that iteration, finalize everything that you need to do, whether it's really make it nice design, make it really easy and friendly, work on the copy, or anything that you want to do here. You get to do that at the last week just before submissions on March 26th. And to make the best use of all of this, we also are going to be doing a feedback session every week, which means that as you are thinking about brainstorming your idea, or you want to see what people think, or what some of our partners think, or what some of these founders who are building these technologies they're using think, you get to join these two sessions. The first one is next week from 3 to 5 p.m. Eastern. The next one is the week after from 9 a.m. to 11 a.m. Eastern. And you can just come on a call and really just get direct feedback. And this behaves like a college office hours. You get to see what people think about this, or if you're stuck, or if you really wanted direct help on a call, and anybody can help you there as our mentors or our partners to tell you what you can do to get unblocked. And I also want to cover a few seconds on our code of conduct. Even though this is an online event, we have a code of conduct that everybody must obey. And the event rules and the code of conduct is on ethglobal.com/rules. You can read everything in a lot more detail, but the gist of it is that please be respectful to everybody in this community, and harassment and abuse will not be tolerated on any form. And specifically about the event rules, anything that you build here is going to be solely owned by you and your team, which means that neither us as ETH Global nor our partners or anybody else owns the IP for what comes out of this. It's solely you and your team members that are the owners of everything that you built. And if you need any help, or if you think that what you're doing for your project might be violating some of the rules, or you may get disqualified for not doing something, you can just reach out to us and we'll be happy to clarify anything and let you know if something is within the guidelines of this hackathon. And all that information, again, is on the website, including everything I'm going to say after, which is the prize stuff, all the talks, all that is there. And you can just go to ethglobal.com/scaling. All right, so before we get to our summit, let's talk about all the stuff that you can actually win and all the prizes that everybody's giving out. So I want to spend the next few minutes on the prizes, and then we're going to kick off with our summit. So let's get right to it. So the first one is from Optimism. What we asked the Optimism team and Maddie to share us what Optimism is doing, what they're excited about, and what they think you should be excited about, and then also the prizes we're giving out. So I'm going to invite Maddie here on stage and tell you more about the prizes.
Hi. My name's Maddie. I'm the head of developer relations at OP Labs, and we are scaling Ethereum by building Optimism. We're part of the Optimism Collective, and together we are building a lightning-fast, scalable Ethereum equivalent layer 2 called Optimism Mainnet. This is all built on the OP stack, which is our open source dev stack that powers all the interconnected layer 2s that will form the superchain. The other thing you need to know about Optimism is that by being part of the collective, by growing the ecosystem, you qualify for retroactive public goods funding, which means you can earn more funding in the future for the impact you have on the ecosystem. So we have 3 hacks for you today. The first one, hack the OP stack. Show us what you would do with your own L2. Take the latest release on Gurley, do something cool with it. Past examples include a Game Boy emulator that ran in the execution environment, or a EVM rollup that used Bitcoin as a data layer. So the top 3 teams will win 5K, 3K, and 2K respectively. Number 2, identity. If you're building identity or reputation, we want to hear from you. Anything involving communities or badges or DAOs, deploy it on Optimism Mainnet and incorporate our attestation service. Look for ways that you can add them to your project. 3 teams will win $2,000 each. And lastly, the pool prize. Any dApp, any tool, bring it to Optimism. It's an EVM equivalent, which means it uses the same tools and flows that you're already used to. It's very easy to ship and start tapping into the Optimism community. If you're looking for resources to get started, we have a lot of them. Head to the prizes page. I recommend starting with the starter kit that we just released. It has support for WAGMI, Foundry, Rainbow Kit, and more. If you're looking for ideas, we have an ideas list. We collect hard, interesting, or just downright unhinged ideas, and we publish them for builders. So if you're looking for inspo, head to this URL. And that's it. I'll be in the Discord. Ping Scav if you have any questions, and good luck and have fun.
Awesome. So you got a quick overview of what all the Optimism prizes are. We're going to talk about a lot more on how rollups work, but I'll just quickly summarize, which is you get to win a lot of prize for hacking on the OP stack. And there's a big emphasis around identity and reputation. So interesting attestation ideas are going to get $2,000 each and up to 3 of those. So you get to see all of that very soon, but let's go on to some of our other prizes. Oh, and by the way, there's also a pool prize, which means that any interesting project that uses Optimism or deploys on mainnet in a meaningful way is eligible to win $400 each. So 10 teams will qualify for that, and they'll be able to receive $4,000 split 10 ways, up to 10 ways. So it could be more. Next up is Polygon. And let's go right into hearing what Steph has to say about building on Polygon.
Hey hackers, I'm Steph Orpilia from Polygon Labs, and I'm here to tell you about the $20,000 in prizes we're giving away to all of the builders who are scaling Ethereum during this virtual hackathon. The first prize is $5,000 for the best Web3 developer or community tool. We want you to scale Ethereum by creating and documenting either a tool, a dashboard, a dev library, a transaction explorer, a DAO coordination tool, or a general Web3 public good that will supercharge development and coordination for the Web3 community and beyond. Our second $5,000 prize is for the best dApp deployed on Polygon ZK-EVM. Get ready for our Polygon ZK-EVM mainnet by deploying your Scaling Ethereum hackathon project to our Polygon ZK-EVM testnet. We've got lots of docs and tutorials to help you start building either with Hardhat or Remix, and we even have a ZK-EVM full stack development tutorial that you can use to start building your dApps. Next prize is $5,000 for the best UX on a project using the dApp Store Kit. This is a community-driven toolkit that you can use to deploy successful EVM-compatible dApp stores using the decentralized dApp Store Kit framework. We want you to build an intuitive, beautiful, user-centric dApp using the kit and explain all of your different UX optimizations and choices within your README. Check out those dApp Store docs to start building. Last but not least, we have $5,000 in prizes for the best use of Polygon ID. Build a full-stack dApp that uses Polygon ID's decentralized identity solution to give your users privacy by default so that they can verify their access rights to use your dApp without giving up any of your personal data. Check out our Polygon ID wiki and our builder tutorials to learn how to set up your own issuer node and verifier service. Those are our prizes. Super stoked to see what you build. If you have any questions at all, please ask us in the Discord. See you soon.
Awesome. So I'll also summarize some of these prizes so you can visually see as well. So the best Web3 developer community tool will receive $5,000 from Polygon. The best app deployed on the Polygon ZK-EVM will receive $5,000. The best UX on a project using the App Store kit from Polygon will also receive $5,000, and the best use of Polygon ID will be receiving $5,000. So it's $20,000 in prizes for a lot of themes that you're going to see as recurring in this world of scaling Ethereum. And you get to check out all the specifics here on the scaling website. Next up is Scroll, and I have Haichen to talk about what you can get from Scroll.
Hello, everyone. We are Scroll. We are very excited to partner with East Global and to be part of the Scaling Ethereum hackathon event. We all know that Ethereum is great and has a humongous community and developers on top of the Ethereum network. It is known to being decentralized by having hundreds of thousands of geo-distributed validators and being secure and censorship resistant. However, due to the blockchain trilemma, Ethereum cannot achieve the scalability as they prioritize the first two properties. So how to solve the scalability problems on the Ethereum? More than 2 years ago, Vitalik posted this blog post about ROP-centric roadmap. So they plan to scale the Ethereum through the ROPs that can process more transactions on the layer 2 and have efficient settlement of finalization on top of the Ethereum layer 1. So Scroll is committed to build an EVM bytecode equivalent of ZK-EVM and ZK-ROP layer 2 to scale the Ethereum. While committed to scaling the Ethereum, we abide by the following 3 principles. First, we aim to build an EVM equivalent to ZK-ROP that can achieve the best-in-class user and developer experience. Second, we keep the security-first mindset when building the layer 2, where the zero-knowledge protocols can explicitly prove the correctness of all execution on the layer 2, and we also actively having external and internal auditing on our code base. And third, we believe that decentralization also matters in the layer 2 context. So Scroll is committed to decentralize across all different layers, including a decentralized prover and sequencer network. For users and developers, because of the EVM equivalence, using the Scroll is pretty much the same as using the Ethereum. Last, let me introduce the Scroll Hackathon and Bounty program in this event. We have total 3 different tracks. First, we just ask you to deploy your smart contract on top of the Scroll testnet. The deployment process will be just like the Ethereum, and you only need to change the RPC endpoint. And second, we love zero knowledge. So show us your best application building new use cases that leverages the power of zero knowledge proofs. And third, we want to see dApps taking advantage of the cheap gas fees and fast block times on the layer 2s. For more information, you can check out the website, and I hope you enjoy hacking on top of the Scroll. Thank you.
Awesome. So to repeat some of the prizes from Scroll, if you deploy your smart contract on Scroll, there's a $10,000 pool prize, which means that any meaningful deployment on Scroll will be splitting this $10,000 equally, and you get to really deploy on a ZK-EVM and really test out what is and isn't possible or what is working as advertised, which should be everything. In addition, there's a category for the applied ZK improvements and empowerment. So 2 teams will get $2,500 as the winners for this, and you can see the specifics on the details on the price page. And there's a cheap and fast block utilizer award category track, and you get to also understand how you can qualify by winning on some of those specific key points that matter to be really cheap and fast on Scroll. So next I want to get to Gnosis Chain. So Gnosis Chain is also giving out a lot of prizes. So the most innovative dApps on Gnosis Chain are qualified to win effectively $20,000. So the best prize gets $8,000. The second place will get $6,000, and there are going to be 2 runner-ups who are going to be receiving $3,000 each for deploying an interesting application on Gnosis Chain. Next up is Filecoin Virtual Machine, or FVM. This lets you really add programmability to your data without having to leave the Solidity world that you're already excited about and understand. So if you are integrating with the Filecoin Virtual Machine, you get to win prizes for all these categories. So the best application for data DAO is qualified to receive $2,000. The most interesting application that works on storage markets is also qualified to receive $2,000. The most interesting tooling on the FVM ecosystem is qualified to receive $2,000 as the best project. There's so many primitives and infrastructure missing for Filecoin Virtual Machine as they ready their mainnet next week. You get to be one of the best projects, making that easier for others to build on top. And there's also a wildcard category, which means that any other project that doesn't fit all these things, but is still super interesting and impressive, will receive $2,000. Next up is Hyperlane. Hyperlane is a permissionless interoperability layer. So as you want to think about modular security between different chains, you get to use Hyperlane. So the best interoperable solution is going to receive $4,000. The best use of Hyperlane's warp routes SDK will receive $2,000 as a prize, and any infrastructure project that is making the best use of Hyperlane will receive $2,000 in terms of helping you scale things on Ethereum. Next up is ApeCoin. ApeCoin Foundation and ApeCoin DAO is giving out prizes for the best integration of a project into the ApeCoin ecosystem. This is the Bored Apes ecosystem, if in case you were not familiar from the DAO side. And there's also a category for the best contribution to the system. So whether that's on account abstraction or anything that you're doing to scale Ethereum, you get to do those tracks and receive effectively close to $10,000 each, 10,000 in total for working on the ApeCoin ecosystem. So if you're excited about NFTs and you want them to be more accessible and fast for everybody in the consumer world out there, you have the opportunity to do so here. Next up is Fuel. Fuel is the fastest execution layer for a modular blockchain. So if you are building a smart contract that's written in Sway language, you get to win a $1,000 prize, and a runner-up will receive $500. Then if you are building a full stack dApp on top of Fuel and deploying it on the Fuel layer 2, you get to qualify for $3,000 of prize for the best use. And if you are using predicates on the Fuel network, 2 teams will receive $2,000 for the first place and $500 for the runner-up category. Next up is Connext. Connext also lets you communicate cross-chain and transfer assets between 2 different chains. So the best cross-chain application will receive up to $3,000 from Connext. And if you end up taking any existing protocol cross-chain, which means you end up bridging something that already is on one of those chains using Connext and help it be available on a different chain, you get to win $1,000. These are very simple bridge contracts. And if you are using the XCall primitives SDK, there's a pool prize, which means that anybody who deploys and sends any data with XCall, you get to split $1,000 amongst yourselves. Next up is Polybase. Polybase is a Web3 equivalent of Firebase. So you get to use Postgres or any sort of relational database or just a key value store quite easily and make your applications real time and quick to use. So the best use of Polybase will get $1,500 and the runner-up will get $1,000. And there's also a massive pool price, which means that all interesting projects that make a meaningful integration and use of the Polybase SDK in the databases will be splitting $2,500 each. Then we have the Graph. Graph is an indexing protocol. If you want to query any of your blockchain data, you get to create a subgraph or tap into an existing subgraph and request that on-chain data as really nice JSON through GraphQL. So the best new subgraph creation will receive $2,000 and $1,000 for the runner-up. And the best use of existing subgraphs will receive $1,400 for the first place and $600 for the runner-up spot. Then we have IntMax. IntMax is a layer 2 that helps you make really quick and fast consumer apps. The best use of IntMax and deployment on that protocol will receive $2,500 and 2 projects will receive this prize. So you get a chance to be one of the first amazing applications on IntMax. Next up is ZK-Sync's Era. This is a layer 2 ZK-EVM designed to scale blockchains. And they are giving out a prize for the best account abstractions on top of a ZK-EVM. You can win $2,000 for that. And 3 teams will get the best developer tooling related prizes for $1,000 each. So if you get to improve, how do we make it easier to deploy more on Era, you get to win $1,000. Then we have Mantle. Mantle is another layer 2 for building modular, just leveraging modular architecture for building and scaling Ethereum and smart contracts. And the best use of Mantle will receive $5,000 in total, so $2,500 for the first place, $1,500 for second place, and $1,000 in third place in the BIT token. Then we have Tyco Network, and they are building a ZK-EVM, which is of type 1. So the best dApps on Tyco will receive $1,500 for the first place and $1,000 for the second place. They are also interested in making infrastructure improvements to working with the type of protocol. And the first place winner will get $1,000. Second place will get $500. There's also a lot of opportunity to make ZK improvements and just interesting applications of ZK. Specific technologies or just SDK and functions, and you get to win $500 for that prize. And if you are one of the team members who wants to understand how do we improve the economics of that network, you can also receive $500 prize for going a bit more into research instead of coding something on ZK-EVM. And we have push protocol. The push protocol is a communication protocol for Web3. So if you want to ping somebody or want to have push notifications that are native to browsers and applications and react on top of on-chain events, you get to use push protocol for all these things and also to chat with people. So the most innovative use case of push across different chains will receive $1,000. This is all about scaling. If you are using the push chat SDK, the best and most interesting use case will get $750. And if you are making something interesting from a UX side of things for on top of the push SDKs, you will get $750 as well. And there's a pool prize of $2,500, which means that all projects that make a meaningful use of push protocol will split $2,500 each. Those are all of our amazing prizes. I know you may have a lot of questions. We'll be able to answer a lot of them here on the chat. If we can't get to them, we'll get to them on Discord. But all that information is available to you on ethglobal.com/scaling, including very specific information about each of the prizes on what qualifies, what doesn't, how you can watch a workshop of somebody telling you how to use them, to the documentation links, to previous examples that they see, to boilerplates. All that stuff is on the website. So with that, I want to stop talking and wrap up with logistics and really go into our summit. So as you get started with your projects, please remember to pace yourself. We really don't want this to be exhausting for you. This event is meant to be intentionally multi-week, so you get to really ramp up your understanding and then tackle something instead of going all in and sacrificing your sleep or health or anything else to really build something that you are excited about that could potentially be the next few years of your life. And we really want you to have fun. So please make sure you are thinking about all these things in a calculated manner and in an easy way so that you get to learn more and understand how you can be more involved in this ecosystem. And remember, all of this thing is about experimentation and learning, which means that it is totally okay if you don't get to finish what you started. Our goal is to help you get there. And if something doesn't work out, that is totally okay. You can absolutely demo something that was partially done and continue working on it after this event ends. And our goal is to help you get to that finish line in however possible way we can. So keep all that in mind and happy hacking. You can find us now on Discord by heading over to ethglobal.com/Discord or your dashboard, and we'll see all of us, all 1,200 plus of us on the Scaling Ethereum channels. All right, that was all the logistics, which went a few minutes over, but I am super excited to talk about what we have now planned for our Intro to Scaling Summit. So let's go right into it. I want to talk about our kickoff summit, which is we're going to highlight all the interesting themes and things that are happening in the world of scaling Ethereum. So today's schedule is as follows. We're going to have Kelvin talk about how rollups actually work and how potentially ZK rollups may not be real. We'll see about that. Then we're going to have Jesse talk about Base. And as you may have heard, Base is the new OP stack chain from Coinbase. We're going to talk about why Coinbase is excited to do this and how they want to bring on the next billion users into Ethereum. Then we're going to have Portal Lambda talk about EIP 4844 in 44 minutes or less. 4844 is a really interesting standard that simplifies so many things to help make these things really consumer friendly. Then Aishan is going to talk about how to think about ZK rollups and the ZK-EVM. This is obviously a really interesting topic because everybody is trying to push this into compatibility and making it easy for others to integrate to. So we're going to learn a bit more specifics about all those things. And lastly, John from Hyperlane is going to talk about how to properly think about the multi-chain future and how you can do interesting things and build cool applications that have context from different chains. So without further ado, let's welcome Kelvin to tell us about how rollups actually work. Welcome, Kelvin.
Hello, Kartik. How you doing? How you doing?
Doing wonderful. And I can't wait to see what you have for the next 30 minutes because I got some reviews on Twitter and I'm excited. So I'll let you take on the floor.
Thank you. Thank you. All right. So, wait. We're good. Am I lagging? Maybe I'm lagging. No, I don't know. Whatever. This is how rollups actually work. This is a talk for all of you who think you know how rollups work, but you don't. I know you don't, because I don't even know how rollups work, and I've been working on them for far too long. I've been working on them since before you were born. This is a talk about how rollups actually work, also known as, where is it? ZK rollups aren't real. That's correct. ZK rollups are not real. I don't believe in them. Birds are not real. ZK rollups are not real. That's correct. My name is Kelvin. I work for OP Labs. I'm building the Optimism Collective because I believe that we can actually change the world with the stuff that we're doing and not just build a whole bunch of garbage. Let's go. All right. I want to tell you a story. I want to tell you about how you think rollups work, because I know exactly how you think rollups work. And I'm going to tell you in this story. Check it out. This is you, right? You're happy. You're on Ethereum and you got some money. Who doesn't, right? In this situation. Then there's this scary bridge smart contract, right? And this is also on Ethereum. And the bridge smart contract kind of gets you over to optimism land, or it kind of protects optimism. I don't know. I know you think that this is how it works. And so then you want to get your money over to optimism land, right? So you send your money over to the bridge smart contract, the scary bridge, and it goes nom nom nom, and it eats it and spits it out on the other end, and somehow it gets over to optimism, right? This is how it works. And boom, now you can open up your MetaMask and
Hey, Kelvin, looks like we ran into an audio issue where we lost your audio. Maybe let's just quickly see what happened there.
you can't hear me?
Now we can, but we couldn't for the last 30 seconds.
Damn.
You should be
Well,
back.
let's try again. I don't know. Whatever. All right. Well, I don't know what I was saying for the last 30 seconds. Something, sequencer, king of the castle, publishes data to some data availability layer. But we know we need to turn the bridge smart contract into a security guard, and we need to give it. And so we add these things, these proofs, right? We add these like fault proofs that protect the rollup. Fault proofs, it's like, so I'm giving the security guard an AK-47, and then everybody knows that obviously ZK rollups are better than optimistic rollups because the marketing department told you so. So that's like adding a second AK-47, but this time it's gold plated. And now we're really protecting the rollup. Nobody's getting past the security guard bridge contract with two AK-47s, and everyone knows that the bridge smart contract is how we protect the rollup, right? Wrong. All of this is wrong. Every single thing in here is wrong. If you think that this is basically how rollups work, you're wrong. And that's okay, because everybody is wrong. They all think that rollups work like this, and they don't. They don't work like this. So I'm going to tell you how rollups really work. All right. So I want you to forget everything you've learned. Here's you. I want you to take your mind eraser and blast yourself in the face with it. What is a rollup? What is a rollup? I'm going to tell you. A rollup is a function over an input array. Okay, that sounds very mathy. I'm using the word function in a mathy way. Function. I kind of mean it to be equivalent. Oh, no, I'm lagging again. Come on, where is it? I kind of mean it to be equivalent to a program. a piece of code, right? A specific, a series of steps that takes an input and transitions it into an output. So let's look at this. What is a rollup? Well, we have an input array, okay? And I'm representing this as an array to try to be, theoretical and special and whatever, but we all know that when I'm saying it's an array, I really mean it's generally a right? They're big old chains. And what's going on? Is it again?
My best guess is that you need to head over to downloadmoreram.com and make sure that you can up your RAM, or if it doesn't work, then maybe disable some local servers that are running and free up some RAM.
Download more RAM.
It's the buffering on the upload. That's our best guess. So maybe kill some tabs and local servers.
I don't even have any tabs. All right, I killed OBS. Maybe it's OBS.
Likely.
But come on. Task manager, tell me what's going wrong.
It's
I have like 2 tabs.
What's
killing my memory? Oh, it's Firefox. Which Firefox? Oh, you know what? I bet I have. Which tab is doing this to me?
And don't worry, we'll be able to edit all these.
I feel like I'm going to accidentally kill my live stream. That's fine. It's all part of the experience, Yeah, I have no clue what's doing this to me. I mean, it's all Firefox, but Firefox what? I guess we can just blame Firefox for all of our problems.
That usually works.
Is it just lagging?
Yeah, it's just lagging, and I think it's because it's not.
What's even happening? I mean, you know what? Like, let's switch to Chrome and see what happens.
We can absolutely do that, and I'll play some hold music.
Be right back. Put some hold music, and I'll speed through the rest.
Take a break, everybody. And in the meantime, if somebody has any questions on how the hackathon logistics are set up, or if you wanted to really know something that we couldn't get to, we can take the next minute to get there. And I was not kidding. So let's actually play some music until Kevin joins back. Oh, actually, he may be here now. All right, let's see round 2. No audio, but at least the video is not laggy. We can't hear you yet, Kevin.
Now? There we go. All right. Kelvin, but not laggy this time. Let's make it work. Come on. All right. Oh, man. Well, what are you going to do? This is why we all work for tech companies, so we can have technical difficulties. All right, let's do this. Let's do this. So, okay, what is a rollup? What is a rollup, right? Boom, a function over an input array. That is a rollup at its core, right? When we think about a rollup, we always have a data availability layer. We have some sort of, there's actually 2 important things about this input array. There's 2 really important properties. There's ordering, and there's data availability. And those two things are both critical. Ordering is really, really important, because if the order of my input array changes, then the outputs that I get change. And data availability is really, really important, because if I don't know what the inputs are, then I can't compute over them. So in a rollup, you have an input array, right? And we usually think that that's a blockchain, but it could even be more than one blockchain put together. But let's just say it's one blockchain for now. And we run some kind of code over that input array, and we generate an output array. This is how a rollup functions, right? So simple. This is the rollup. This is the rollup. And I want to note that there's not necessarily a one-to-one correspondence between the inputs and the outputs. It could be that one input produces multiple outputs, or that multiple inputs are required to produce a single output. But the point is that this picture right here, what you are staring at right here, is the rollup. This is the rollup. When you think of a rollup, it's this thing, right? There's some inputs. That's the L1 blockchain. There's some code. That's the rollup node software. And it produces some outputs, and that's the rollup blockchain itself. And so there's a very important question, which is, how do you actually append stuff to this input array? Because a rollup is not useful unless we can put data into it and add transactions to it. And so we need to be able to append things to the input array. So generally, one way of appending inputs is to append things directly, right? So here's the input array. You know, it's the blockchain. We're at the latest block. Here's you. You're happy. You want to put a transaction in. Depending on the capabilities of the layer 1 blockchain that we're interacting with, you can usually just insert a transaction directly, right? So most rollups have this capability. There's some sort of smart contract that you can interact with, where you can send a transaction to that smart contract, and you can insert a transaction into the L1 directly. That adds stuff to the input array, which also, as we see in this picture, will produce outputs, right? So that's approach number one. And then a very common secondary approach is this thing called a sequencer. Now, a sequencer, the idea of a sequencer is that this is very inefficient. Posting data like this is very inefficient, because there's a lot of fixed overhead when you submit transactions to a blockchain like Ethereum. In Ethereum, specifically, there's this 2100 gas base cost for every single transaction. That's actually a lot of gas for most transactions, when most transactions can be compressed down into a lot less. So we tend to want to be able to batch things together, which allows us to do this fancy compression stuff and really take advantage of sort of economies of scale. So we create this thing called a sequencer. The sequencer is our little king of the castle. And essentially all the sequencer does is that it takes user transactions and it bundles them together. And what it's going to do is it's going to create bundles of these transactions, and it's going to publish them to the data availability layer, to your L1 system. But the important thing is that we want a good user experience. Getting these bundles together can take quite a while. We don't always want to publish these bundles immediately. And so what the sequencer does is the sequencer pinky promises that they're going to include this bundle in the future. And you see, I've represented this pinky promise by highlighting this in gray. And essentially, what we can do is that we can run our rollup code over what we think the rollup or the input array is going to look like in the future. And we can generate these outputs, and we know what the outputs are going to look like in the future. And this is before the sequencer has even published anything to the L1. We just know that this is what it's going to look like, assuming that the sequencer comes through on their pinky promise. And eventually the sequencer sends off the transaction to the actual data availability layer, and this becomes real. So the inputs become real and the outputs become real. Right? So that's the gist of the rollup. This thing that I've represented to you is the rollup. And I'll note that I haven't talked about any sort of proof mechanisms or ZK rollups or optimistic rollups, because all of that stuff is fake. And I'll explain to you that in a minute. So the next thing is, well, we have systems, right? And we want to connect these systems with other systems, because connecting with other systems is useful. If we just had this rollup, I guess we could interact in our own little bubble here. And this is what you might call a sovereign rollup. right? It's, you know, you can post data to this data availability layer. You can interact in your own little bubble. But if we want to interact with other things, we need to be able to connect with other systems. So how do we connect with other systems? Well, we have an automatic connection to the parent system, where the parent system is where the L1 data lives, where the inputs live, because sort of, I want to do the spinny thing. By definition, that's how the rollup works. The rollup is taking its data. It is defined by the data and the ordering of that data, right? So we have this automatic connection to the parent system, which is why I can include transactions by sending a transaction directly to the parent system, because just by definition, I am deriving the rollup from that parent system. But what about other data sources where you don't have this type of trustless connection, this definitional connection to these other data sources? What if there's another blockchain? There's Kelvin's Super Rollup 2, and I want to bridge Kelvin's Super Rollup 2 and Kelvin's Super Rollup 1, right? I want to get information from this other rollup into my rollup. Well, like we said, anything from the input is trustless because the rollup is defined by the input. But for anything else, we need a convincing argument, right? Why should smart contracts on my rollup listen to stuff that you're saying over on your rollup, or that smart contracts are saying on your rollup? Why should I listen? Because at the end of the day, they are two separate independent systems, and I don't have this direct connection. So why should I listen to you? Well, we need to be convinced, right? So how do we do this? How do we generally be convinced of things on other chains? This is just asking how bridges work. How do bridge protocols work? Well, there's a lot of different ways that we can make bridge protocols work. People do authority-based bridge protocols, right? Which is like, oh, where is it? God coming down, with God's little weird finger coming down and saying, this is what the other rollup or the other blockchain looks like right now. Just trust me, right? Listen to me. And if you trust the authority, if I'm a smart contract on my chain and I trust the authority and I'm like, whatever, God's not going to lie to me, who cares? Then I'm fine. Then we have sort of a strengthening of this. We have threshold authorities. So maybe, God has 3 hands now and 2 of them have to come down. We have light clients, which is sort of the ugly little brother of the chain coming in and saying, good enough. It's a representation of the chain. It's not the chain itself, but it's a representation of the chain with pretty good trust assumptions where we can say, okay, I'm convinced, that this is the state of the other chain. We have fault proofs, right? Fault proofs are essentially 2 people going back and forth saying no you repeatedly until we figure out who's right. And then we have validity proofs, and that's the math nerd coming in with such a convincing argument that you simply can't reject it, right? This is how we communicate between blockchains. This is how blockchain communication happens. If I have a third-party chain and it wants to communicate with me, it has to convince me what its state is. Now, what's the worst thing that can happen in this situation? What's the worst thing that can happen when somebody is trying to communicate with me in this way? Well, I would argue that the worst thing that can happen is that apps on our chain could be convinced of something invalid, right? The mechanism by which I'm convinced of the thing that's happening on this other chain could break. And it could convince me on my chain that something happened on your chain that didn't actually happen, right? Where's my, oops. And I want to put this in caps because I'm going to come back to it later. But this does not directly impact the other chain. What has broken here is my view of the other chain. The other chain is running independently, right? It could be that the other chain has absolutely no clue that I'm even trying to read data from that other chain. If my view of if that other chain breaks, the other chain does not break. I mean, my smart contracts might break because I might be making decisions based on bad data, but the other chain doesn't break. All right. So let's get to withdrawals, right? Because I've talked about all this stuff and I've talked about a whole roll-up system, but I haven't talked about this bridge stuff and the proof mechanisms yet. So what is it? What about withdrawals, right? So what are withdrawals? Let's look at this picture again. We have the roll-up. This is the roll-up. When you think roll-up, I want you to think about this. We're adults now, so we know that that I was sort of lying to you and that these things are blockchains. What are withdrawals? Well, I want to put these pieces back together, and I want to show you something. So here's you, and let's say you want to send some funds from the parent chain into the child blockchain, into the L2, from the L1 into the L2. What do? Well, you use the mechanism that we talked about earlier to directly add inputs to the input array. You send a transaction to the L1 blockchain. This adds an input to the input array that tells the L2 kind of trustlessly that it can mint funds on the L2. All right, so this is the same picture that we saw before. It's one directional. It's one directional. And again, there's nothing in here about proofs, optimistic or ZK. But now I want to get my money out. So I light my money on fire on L2 and I tell the L1 that I burned it. And the L1's like, I have no clue. The L1 doesn't read the L2. The L1 has no clue what's happening on the L2. And so the L1 says, prove it. Right? This smart contract on L1 that is locking up these funds says prove it, and so you got to put on your judge wig or your lawyer wig, and you have to prove it. So let's go to court. Right? Here's you with your lawyer wig. Here's the smart contract on L1 that has the key to your safe. How do you prove it? Well, one way to prove it is you could use a proof of authority, and that's God's finger coming down. And then there's a threshold system, and then there's light clients, and then there's fault proofs, and then there's validity proofs. Wait a minute. This is exactly like what we just did when we wanted to receive data on the rollup. It's the same image, but in reverse. Just like when we want to receive data, when we want to send data to the L1, we need to make a convincing argument to the L1 about what, and this applies to any chain. When we want to send data to any other chain, sending data is like receiving data, but in reverse. That should seem obvious to us, but in our mental models, it traditionally isn't, but it is obvious. Withdrawals are just another chain receiving data from the L2. Yes, that's how this works. Withdrawals, in this case, the standard thing is that withdrawals on the L1 is the L1 receiving data from the L2, just like how we talked about how the L2 can receive data from other chains. It's a symmetrical image. And so when I talked about this, what's the worst thing that could happen? It doesn't directly impact the other chain, right? The worst thing that can happen is that the smart contract on L1 releases some funds that it shouldn't release, which is bad, but it doesn't directly impact the L2. And this is a really, really, really important property to understand. If the bridge breaks, the rollup does not break. This is such an important thing to know about rollups. I think so many people have this mental model that the bridge defines the rollup. But in reality, the bridge does not define the rollup at all. The bridge is a view into the rollup. If the bridge breaks, that is obviously bad. Assets on the rollup can become under-collateralized. But if the bridge breaks, if the bridge finalizes a state that is not what's in the rollup, that is a problem for the bridge. The rollup is still going to continue operating as if nothing ever happened, because just like I said in the slide many slides ago, the rollup may not even know that the bridge exists. And in many cases, the rollup has absolutely no clue that the bridge exists. So let me get to the second part of this talk, which is that ZK rollups aren't real. Now, obviously, ZK rollups are real in the sense that people create these things and they call them ZK rollups, right? You know, we've got ZK Sync, we've got Polygon ZK-EVM, the wait is over, but I'm still waiting, and then we've got Scroll, right? When I say ZK rollups aren't real, what I really mean to say is that the ZK part is not fundamental to the rollup. In the way that we just described rollups, there is a rollup part. And then on these other chains, there's an implementation detail of a smart contract on a completely different system that has nothing to do with the rollup, that either uses a ZK or an optimistic or a light client or an authority proof or many different sort of things to establish a view into the rollup on a completely different system. The ZK part is not fundamental to the rollup. There is no such thing as ZK or optimistic rollups. There are just rollups at the end of the day. There are just rollups. And then we create these view mechanisms on other systems, completely separate systems. And they have proof systems, and those things are ZK or optimistic. But if you tie these things together, if you think that there's a thing called a ZK rollup or an optimistic rollup, and somehow ZK and optimistic rollups are fundamentally different, you're going to be at a disadvantage in the mental model for what a rollup is. And the reality is that I think the optimistic crew gets this now, but why not the ZK crew? What is this? And I think the answer is that ZK is really hard. And people feel like they have to create the ZK proof, because if you don't create a proof, if you don't create a ZK proof, are you really a ZK rollup? Right? That's sort of, are you really a ZK-EVM if you don't have the proof? So they start with the proof. And they build this proof, right? They build this proof system, and they spend all this time building this proof system, and it's really, really hard. And then they sort of cram the EVM inside of this proof system. They shove it in, and it's sort of, you know, it looks like this, and it's kind of like, it doesn't want to be in this tight little space, and the parts are sticking out, and it's not quite the EVM. And then they pat it on the head, and they say that it's just, you know, it's just looking extra equivalent today. You know, but it's not really the EVM. I mean, that's whatever. But what's the correct way to do this? What's the right way to build these systems? The right way is to build the EVM in all its glory. You know, this is weightlifting EVM, super EVM. And what we want to do then is we want to build the box around it. Instead of cramming the EVM into the proof system, we want to create a proof system around the EVM. And this is what's really going to make it obvious that ZK rollups don't exist, or optimistic rollups don't exist. Really, it's just rollups. And then we want to make a proof system around it. That's the gist of the talk. I cut it a little bit short because we had some technical difficulties earlier, but thank you for coming to my TED Talk. Remember that ZK rollups aren't real. Optimism is not a rollup. Optimism is an upgrade to capitalism. Join the collective, change the incentives, and you will change the world. Come check out the vision of what Optimism and the Optimism Collective is trying to do. Come check out the OP Stack docs if you want to build your very own blockchain, your very own layer 2 today. And, you know, I just want to say, understand this property about rollups. Understand that the proof system is not fundamental. What you want to do is you want to build a really good rollup. And then you want to build a proof system on top of it. And if you build a rollup that way, you can build a rollup where it doesn't matter whether it's ZK or optimistic. You can slap a ZK proof on it later. You can slap an optimistic proof on it later. You can slap 10 different proof mechanisms at the same time. That's the right way to build rollups. But if you tie the bridge to the rollup, you're thinking about these things wrong. The bridge is an independent system. The bridge is a view into the rollup. So think about that. That's how rollups really work. ZK rollups aren't real. Optimistic rollups aren't real. Join the Optimism Collective. Optimism is an upgrade to capitalism. Change the incentives and you change the world. Have fun. Build something cool. And if you want to fight me on Twitter, we can fight on Twitter. Thank you so much. And have a wonderful day.
Amazing. Well, it still worked out at the end. We got everything, and we'll make sure that once this goes edited out on YouTube, it's smooth and perfect.
Thank you.
And that was a really informative talk. I think it's a really good way to think about those primitives and just break them down into those smaller components that actually matter. And personally, what I got out of it was that optimism is the only real blockchain.
Only serious blockchain.
Only serious blockchain. You're right.
There are other real
There are other real blockchains,
but
yes.
Optimism is the only serious one. That's correct.
Basic. Well, Evan, thank you so much for joining us, and we'll see you all on Discord hacking away on the OP stack.
Thank you. Bye, everybody.
All right, next up, I want to bring on Jesse to talk about everything base. You probably saw a lot of this over the last week, and if anything, this is all Twitter and crypto Twitter was talking about. So I'm going to give him the stage here to talk about how do we bring in the next billion users into the Web3 ecosystem. Welcome, Jesse.
Thanks, Kartik. Hello, everybody, and huge round of applause to Kevin Filcher. Amazing, great talk. Really love that. We're excited and grateful to be working with the Optimism team. I'm ready to dive into how we're going to bring the next billion users to crypto. Just to quickly reintroduce myself, I'm Jesse. I'm the kind of first contributor to Base. I lead all things Base day to day. And I'm going to do kind of a high level overview of kind of what is our vision with Base and Coinbase for kind of how the on-chain economy and architecture is going to develop. Then I'm going to share a little bit more detail about what is Base. And then I'll close with a few minutes of kind of like, how do you build on Base? How can you build on Base during this hackathon over the next few weeks? And then if we have time, which we may not, we'll do some Q&A. But excited to be here. Thank you, ETH Global, for having me. Thank you, hackers around the world, for scaling Ethereum. So quickly, just a refresher, Coinbase. What is Coinbase? You've probably used it, Coinbase.com, Coinbase Wallet. We've been building in the crypto economy for 10 years. I like to say we have 110 million users and 80 billion TVL. That TVL right now is primarily stored in off-chain Coinbase.com. That is custodial. But one way I've increasingly been thinking about that off-chain custodial Coinbase.com is almost like a roll-up or like an L2. It's just a really bad one. It's private. It is centralized. It's not transparent. And a lot of what I've been thinking about for the last many years is how do we move our users, our assets out of that kind of private L2 that doesn't work as well as it could and into new on-chain systems that give our users more flexibility, more autonomy, more agency, and bring them into this kind of burgeoning crypto economy that we're so excited to be helping to build. And I think as we're thinking about making that move for our customers, the thing that's really motivating us is this thesis that on-chain is the next online. And so I want to kind of quickly talk about what does that actually mean. We at a high level think about kind of the last 40 years of kind of building applications in three phases. The first phase was kind of pre-2000, which was the offline application development phase. This is when people were writing, code for computers or mainframes. At that point, information and money was still very much managed by central gatekeepers. And the folks who were building applications were moving really slowly and only had so much reach. You would write an app, you'd put it on a floppy disk or a CD, and then the best you could do is distribute it to everyone and hope that they opened up that piece of mail and put it in their computer. But for the most part, they didn't. And that meant that newspapers and banks were the way you could really kind of influence people. And then the internet happened. And it was this crazy thing. And for the first time, information became permissionless. And this created a whole new wave of innovation. We had millions of developers all over the world, and anyone anywhere could build apps for the internet that anyone anywhere could access. And developers started moving 10 times faster than they could before. We saw the rise of Twitter, Facebook. We saw the creation of video chat, of streaming. Literally what we are doing here right now is only possible because of the online era, unlocking information to be a permissionless thing that anyone could build on. And yet, money still had gatekeepers. If you wanted to build an application that touched money or value, you had to interact with banks, you had to interact with the government. You could not build something global for the people. And we believe that right now we are sitting on the precipice of the next big change. And that is moving from an online economy into an on-chain economy. And moving for the first time from a world where money has gatekeepers and value has gatekeepers to a world where both money and information for the first time are permissionless and anyone can build on them. And in that world, anyone, anywhere, you, wherever you are in the world, are going to build applications that use value, that use money, that use information that anyone, anywhere can access. And once again, we are going to see another 10x, 100x growth in the amount of impact that developers like you can have on a day-to-day basis. And so Coinbase has been building for this on-chain future for a long time. We started in 2012. At the time, there was no smart contracts. There was only Bitcoin. We made it the easiest place to buy Bitcoin. And then really starting in 2018, we began thinking about how do we go bigger? How do we come more on-chain? We launched USDC, we launched Coinbase Wallet, we launched CBETH, we launched the DApp wallet and the Coinbase app. All of these things gave our customers real on-chain experiences and were built by developers who were writing in smart contracts, building on this on-chain platform. And with the launch of Base, which I'll talk about in a second, which is our Ethereum L2, we are catapulting ourselves into the next phase of this on-chain future and starting to create a platform that makes it easy for Coinbase developers and developers globally to be building on-chain. And as we started thinking about Base, the thing that actually motivated us and the thing that got us to building an L2 was a process that we ran in 2022 where we tried to say, okay, everything's moving on-chain. We see that this is going to be an incredibly high impact new venue for developers to build. What is that actually going to look like? And how does Coinbase fit into it? And after a year of kind of digging, we took away 3 key takeaways. The first key takeaway was that EVM is going to be the primary developer platform that most developers are building applications for. This came from working with internal teams, working with external teams, observing that today EVM has 10x the devs, dApps, TVL compared to any other platform, and that lead is only growing. And so as a result of that observation, what we've decided to do internally at Coinbase is build all of our on-chain products EVM first, both for our developer tools. So our internal teams have really easy way, paved road for getting started building on-chain, but also for our user-facing products. So everything works for all of the incredible EVM-powered products that y'all are building. So that was the first big takeaway. The second big takeaway was that Ethereum is going to be the primary L1. It's going to be the thing that provides security, decentralization, neutrality, and it's going to be the thing that enables scaling on top of it. And so for the last year, Coinbase and Base have been investing in scaling Ethereum. We've done that through contributing to something called EIP 4844, which is an upgrade to Ethereum that's going to make it so rollups like Optimism and Base and Arbitrum are 10 to 100 times cheaper than they are today and get us closer to what we think about as kind of the magical fee number, which is less than a cent for the average transaction. And then the third takeaway, and this was one that was actually pretty surprising to us or different than where we started, is we started thinking about this assuming that there was just going to be one L2 and that the most important thing for us was kind of picking the right L2. And I think after a lot of thinking and working and talking with teams, we ended in a place where we believe now that there's actually going to be many of these things and that they're going to work together, they're going to interoperate, they're going to standardize, and they're going to scale Ethereum collectively. And that as Coinbase, our duty is to contribute to that. And that is why we're launching Base in collaboration with Optimism on the open source OP stack so that we can start to have the tools that are freely available to anyone, anywhere to build and scale layer 2 on top of Ethereum. And we can ensure that those tools work for everyone and create a platform on top of which we can have many chains that interoperate seamlessly together. And so with all that context of our on-chain vision, our North Star is how do we bring 1 million developers and 1 billion users on-chain? And Base is our contribution to that. And so if you haven't heard it already, if you didn't see the blue dot on Twitter, Base is an Ethereum L2 that's built to scale the crypto economy. It's powered by the OP stack. It's empowered by Coinbase, which I'll talk about in a second. It's a fully open ecosystem, so anyone can build there. Coinbase will seed it with our users, our assets, our infrastructure, but then the magic of what will come on Base will come from all the developers everywhere, including y'all. It's low cost. We're going to have some cool rewards that we do for developers we're building there, and it's all secured by Ethereum. One thing that I want to dig in on is that component of empowered by Coinbase. What does that actually mean? When I say empowered by Coinbase, what that actually means is if you look at the Coinbase products today, we are increasingly starting to create opportunities for organic distribution of our user base, those 110 million users, to applications. And so this image on the left, you'll see this is our new Web3 page. If you go to coinbase.com/Web3, this is what you'll see. It's basically an app store. And it's ratings, it's reviews, it's search that allows any of our customers to start to find the best apps that they want to use. And over the next year, we're going to be building more and more of these tools. And the goal is to make it so that any user can access any app with a safe, trusted, easy to use interface, and that we actually bring those customers to developers like y'all, so that as you find product market fit, you can grow your business. And so that's the organic part of Empowered by Coinbase. The other side of Empowered by Coinbase is we're also starting to build what we call paid tools or acquisition tools. And so on the top left, you see a few ads. That's CoinLedger, that's LooksRare. We believe that there's an opportunity for us to rebuild the infrastructure of kind of advertising to make it more open, more transparent, more accessible to anyone, and to use that as a way of bringing the 110 million users that we have to the incredible application developers like y'all. And so the easiest way to think about it is imagine you build a lending product and you have 50 million TVL and your goal is to grow to 1 billion TVL. And what you find is that there's a certain class of users, maybe people who have a certain amount of money or hold a certain amount of assets, that are really high return on investment for your protocol. If you can get those users, they'll use your protocol, they will put their assets in it, they will help you grow your business, and you're willing to pay for that. And this is kind of the thing that we've seen from businesses forever. If they find product market fit, when they find product market fit, they're willing to pay to acquire the users that are going to be incredibly valuable for them. What we want to do with Coinbase is we want to make it so for anyone who finds those users, who starts to understand who those users are, we can give you access to those users. And we can do it in a way that protects their privacy. We can do it in a way that lives up to the best kind of values of decentralization and transparency that Coinbase has worked to embody over the last many years. And we can also do it in a way that delivers real value to your business. And so when we say empowered by Coinbase, what we mean is our goal is to, through organic and paid distribution, take the 110 million users that we have in the Coinbase ecosystem today and bring them to developers like you so that you can grow your business, you can grow your protocol, and you can help us get to not 100 million users, but 1 billion users and then 5 billion users using the on-chain crypto economy every day. Now, a few more things that you might want to have questions about with Base or you're interested in learning. The first thing is Base is going to be fully permissionless and it's going to gradually decentralize. This is something that a lot of people have asked. We believe that Base must extend and inherit the permissionlessness of Ethereum. And so that's why we're working with Optimism. That's why we're prioritizing decentralization. There's 3 big axes on top of which we think about decentralization. The first is block building. The second is protocol upgrades. The third is validator set. And we're going to be making significant progress on each of those this year and defending the kind of permissionlessness of Ethereum in Base as a layer 2. Talking a little bit more about that relationship with Optimism, Base is built on the OP stack. If you haven't heard of the OP stack or you didn't watch Kevin's talk just now, it's an incredibly powerful open source toolkit. It's MIT licensed, which means that anyone can use it, fork it, update it, contribute to it, and we are joining as the second core developer of the OP stack. And what that means is that Base and Coinbase are going to be taking our resources and putting them into accelerating the roadmap of the OP stack across things like security, decentralization, scalability. And what that means is you all are going to have a better toolkit for building your own chains if you want to. And the chains that you deploy on, like Base and Optimism Mainnet, are going to be faster, lower cost, and more secure. The second thing that we're doing as part of this collaboration is we are contributing a portion of the sequencer revenue from Base to the retroactive public goods funding model that Optimism has been pioneering. And what this means is we're taking our money and we're putting it into funding those public goods that make Base possible, make Ethereum possible, make the internet possible. And we believe that this is a critical thing for everyone to be doing as they're starting to contribute to this shared platform that is scaling the on-chain crypto economy. And then finally, the third thing is we're going to be working with Optimism and Ethereum to champion this decentralized on-chain crypto economy. I just mentioned it. We're making Base permissionless. It is a key component of what we believe the infrastructure of this crypto economy will be, and ensuring that that infrastructure remains open to everyone in the world is an absolute top priority for us. A little bit more color on timeline. If you haven't already seen it, we launched the testnet for Base 2 weeks ago. You can go start building on that today at base.org. I'll share a little bit more about how to get started in a second. We're working towards the mainnet in Q2. We're going to start with a genesis that's going to be more quiet, where the chain will start running, and then we'll gradually build towards a more go loud launch where all the Coinbase products are going to be integrated, as well as a ton of other ecosystem builders. And then as we progress through Q3, we'll have more rapid improvements to the security, the cost, the decentralization of the chain. And the key takeaway to know there is you can start building on Base today. And anything you start building on Base today is going to be on track to launch sometime in the next few months as we bring the testnet to mainnet. So now I want to dive a little bit more into how can you build on Base. There's a few steps. The first is that you have to bridge some assets to Base. Base is running on, the Base testnet is running on Gurley, Ethereum Gurley. So if you go to bridge.base.org, you can take your Gurley assets and you can bridge them. It's really easy. It goes pretty much instantly from Gurley to Base. And at the other side, you'll have Ethereum on the Base Gurley network that you can use for gas. If you don't want to bridge, that's okay too. Coinbase has faucets that you can use. If you go to coinbase.com/faucets, you can really quickly get 0.1 Gurley ETH per day, and that will get you started with deploying contracts. If you don't want to go to coinbase.com/faucets, or you want more Gurley ETH than 0.1, oh, wow, I'm missing a slide. Where'd it go? Did it get deleted? Oh, I gotta go back. Sorry. There we go. If you want more than one Gurley ETH, let me get there again. If you want more than 0.1 Gurley ETH, every day or most days I am tweeting saying, tweet at me with your ENS name, and I'll send you one Gurley ETH. And so if you go to twitter.com/Jesse Pollock right now, you'll see the top tweet or one of the most recent tweets, and you can just reply to that with your ENS name, and I will get you started with one Gurley ETH. And so last kind of closing component, if you want more information on how to get started, we have some guides. You can scan this QR code, and that will take you to a guide for using Hardhat, for using Remix. We're updating and improving this content every day. So keep going to docs.base.org, and we will make that happen. And so with that, I'm done 5 minutes early. And I don't know if Kartik is around, but we could open it up for questions, or we can wrap early.
No, well, let's do questions. This is a hot topic in the sense that there's so much chatter around it, but everybody's just been busy and just managing all the inflow. So I have a couple questions, and as people kind of type their questions in chat, I'll field them too.
Awesome.
My first question to you is, obviously you talked about how people can build and why you're doing it, but how do you actually define success here? Is this to you the fact that you get to measure Coinbase brought in millions of users, or is it the fact that Ethereum itself became bigger, or something different, or a mix of both? What do you think is considered good?
Yeah, so if you look at the crypto economy today, I think we have a few million people who are using crypto on a daily basis, or maybe less than that, 1 to 2 million people who are using crypto on a daily basis. I think at the highest level, success is like 5 billion people are using crypto on a daily basis. And so, how do we get there? Our thesis is we need to make it easier for developers to build useful applications. Too much of crypto has been about kind of trading historically, speculation, and we're just entering the point where we have the infrastructure for developers to build non-speculative applications, and we want to make it really, really easy for developers to do that. And so our kind of North Star there is 1 million developers. And I am overly ambitious maybe, but my goal is to get 1 million developers this year through working with folks like ETH Global, Third Web, all the incredible kind of folks we've been working with. So the first measurement is like, can we get to 1 million developers who are building on Base and contributing to the broader crypto economy? And then the second one is, can we make it really, really easy for users to actually use those applications? So when developers build useful applications, developers can just do it without thinking. And it's a no-brainer. And it feels as easy as any product that they would use today. And I think that's where like Coinbase comes in. We're working really closely with the Coinbase team, but also the Rainbow team and the Frame team and other wallet teams to make it so that the experience of users actually accessing applications on Base is very easy. And that's where the kind of billion user goal will come in. And my goal is, again, overly ambitious, but 1 billion users next year. And so that's what we're going to be looking at. Like when I wake up every morning, I'm like, what are we doing to get to 1 million developers and 1 billion users today? And we want those people to be obviously coming through Base, but then going everywhere in the broader kind of Ethereum superchain. We think about Base as a bridge, not an island. Something that actually enables people to come from off-chain to on-chain, but then through interoperability at the chain level and then support across the Coinbase products, we'll make it so that users can transact wherever they want. So if they say, hey, I want to go use this application over there, we want to help them do that.
Oh, no, that's amazing. I think one thing that I like already is that you are, in a way, baking in the fact that this has to coexist with everybody else and not my own thing. And
yeah, I mean,
you need that. Otherwise,
Base and Coinbase we're just one part of the broader crypto economy, and y'all are the people who are building. We're the ones who, have been building, and we're going to create infrastructure, but y'all are going to be the ones who create the applications that billions of people want to use. I'm so excited that all of you are here today to be doing that.
No, I think that's a wonderful note to end on, and we kind of get to see this live over the next 6 months, and get more devs to build on it and see if they can break things so you can fix them. And
amazing.
I go faster. So,
amazing. Thanks, everyone. Docs.base.org, base.org. If you want one free Base girly testnet ETH, find me at twitter.com/Jesse Pollock. Reply to the tweet that's right there, and I will get that to you with your ENS.
Amazing. Well, thank you so much, Jesse, and looking forward to seeing what people build on Base.
Thanks, everyone.
All right. See ya. Next up, I want Porto to come on and talk about EIP 4844. And there's a lot of 4844 stuff going on here. Some of you may know how this helps us get to really, really cheap data and transactions. And there's a lot more that people don't talk about. And we're going to take about 44 minutes, maybe less, to cover all those specifics. So we'll get Porto to join us in a second as we get to load up the slides. And in the meantime, if you have any other questions that come up for Porto or Jesse or anybody else, please let us know, and we'll be able to kind of relay those questions to you and to the speakers and get those answers. So without further ado, let's welcome Porto. And hi, how's it going?
It's going very well. Thank you for the introduction.
Absolutely.
Hello, everybody. I'm Proto Lambda. I work at OP Labs. I'm going to present about EIP 4844. Okay, so let's jump into this. 4844 is an EIP. It's about a year old now. It was started during ETH Denver. And, well, let me get started with the actual slides, if this works. A moment. There we go. Right, technical issues. It's like a curse starting with the presentation of Calvin. So, hello, I'm Proto. Work at OP Labs. proto-dank sharding is kind of a meme. It's this name that's been attached to Fort44. Fort44, what it really is, it's the first iteration of the sharding roadmap of Ethereum. And this longer-term vision is like inspired by the work by Dankat and by Vitalik and others at the research team. However, we cannot wait. We want sharding on Ethereum today. Like, these are multi-year research processes, and so instead of trying to do everything at once, we, as engineers, we are looking to build this first iteration. And this is a collaboration between OP Labs, Coinbase, as well as all the different layer 1 client teams, and the research team, of course, of the foundation. That's putting together resources to implement the transaction pool changes, the blob storage, the syncing, everything that's involved in this first iteration of sharding. And so what I'm going to tell you about is really like, what is this thing? What is Fort44? Why are we doing this? Like, how does this work on layer 1? How does this work on layer 2? And then I'll talk a little bit about the fee structure of Fort44 and about the clients and the progress we've made so far. So what does EIP Fort44 do? EIP Fort44 increases the data availability for layer 2 to about 0.5 megabyte per layer 1 block. For context, the current data availability is around 70-ish kilobytes. And so this jump up in data availability increases the capacity that is there for rollups to post their data to. If you've watched the talk from Calvin about how these rollups work, then you are now familiar with the concept of a data availability layer. The data availability layer is kind of hijacked on top of the legacy Ethereum. We use call data, which is meant to be an input to the EVM. But instead of using this call data, what we intend to use is blob data. Blob data is like a specialized resource. And so we can have more of this without putting a lot of more strain on these layer 1 nodes. And as you can see, rollup popularity has been rising. Like, around end 2020 is when the idea of a rollup-centric roadmap started to really take off, around the launch of the Beacon chain. And since then, the rollups have taken more and more of the data of layer 1. So half of the current capacity, like half of the data inputs to the EVM, are not actually inputs to the EVM, they're rollup contents. And so we want to change this and optimize so we can have more of these contents. Because why? Well, 97% of the fees on layer 2 today are actually just paying for the call data on layer 1, and they're basically misusing this resource. This resource is not efficiently utilized to derive the layer 2 chain. Well, this is kind of what it looks like. So this is where transaction fees are going, and the thing we want to try and optimize. Like, this total could be much, much smaller if we tackle the largest cost factor here. Like, as a layer 2, we're not asking a lot of fees. It's primarily just data fees, and we'd rather have a lot more users that can adopt Ethereum through layer 2. And we can do so by utilizing shard data to host all the content. So this is what layer 1 looks like today. Merge is complete. Got to remove one slide leading up to this. In like the modular blockchain steps, we have a consensus layer and an execution layer now, but it's only the start of modular blockchain. What we are looking at today on Ethereum really is kind of this hack where we have layer 2 and it's attached to the call data of the EVM. There's no clean separation, and although we have these fault proofs and validity proofs to verify outputs of the EVM, we kind of have this strong coupling idea, or like how a rollup should be secured. It's not efficiently attached to layer 1. And so what we want to do with 484 is to model it like this, where we have a consensus layer, we have an execution layer, and there's this layer 1 data, which technically speaking, it's part of the consensus layer. The consensus layer holds onto the data and votes on which data is available or not. And then through the execution layer, the data is registered and paid for. But this data is really meant to provide for these rollups for layer 2 to scale. And this is only the start. Like 484 is an incremental step towards full sharding. What we're looking at after 484 is full dank sharding, which basically means we can support a lot more of these data blobs. And how do we plan to support this? This can be supported with data availability sampling, which is this security technique for validators on the network to randomly poke others on the network to see if data is available. And the poking here, the sampling, can be dramatically improved using redundancy and using these efficient proofs over the data. And so I'll talk a little bit more about how these blobs are structured. They are structured in a very particular way where they are future compatible with this full sharding vision. Okay, so how does EIP 484 really work? Now there is this new blob transaction type, and the blobs that are paid for, this content, the data, is held into the beacon node in the consensus layer for 2 weeks approximately. And what this means is that we separate this ID of syncing and this ID of security. Syncing, you should be able to fetch the layer 2 state from any place, just as with layer 1. The critical part really is this last 2 weeks of data. And so as intuition, you could think about a CDN or some service where it's much, much cheaper to provide, host, and like cache the data and distribute it if the data doesn't change versus changing data. And similarly, like this recent amount of data, it's more unstable. It's still being voted on, it's uncertain. The layer 1 might propose it, but not actually make it available to those that rely on it. And what we want to secure really is that any verifier of layer 2 is able to get the data and then able to use the data on top of this older state of layer 2 to get the very latest state, the tip of the chain. And then using the latest state, they can produce any, like with full data, they can produce any proof that they might need to counter any false claims on layer 1 or to produce a validity proof themselves on layer 1. And this is what secures the rollups. It's really this recent data that's important to make available. And then the older data we can optimize. And so this task of Ethereum changes to how can we make the data available to these layer 2 networks that rely on it to secure all their full assets, right? This is special data. It's not just that we can use regular storage services. It has to be available. And this availability, I'll talk more about this. It's just a strong feature of sharding where this type of resource that Ethereum was lacking is dramatically increasing. And then you ask, well, who's paying for this resource? How does this work? There's this new transaction type. And similar to how you can run the EVM, you can now also attach data to Ethereum to make it available. And what this means is that there's a regular EIP 1559 transaction. And the transaction contains some pointers. And these pointers, they point to these separated blobs. And the idea here is that the transaction registers the fee payment and is processed by the EVM. whereas the blobs, they are separated and they go into the consensus layer, into the beacon node. So here's the transaction in more detail. The nice thing about this transaction is that it's structured using the latest encoding format, SSE, that the beacon chain also uses. And then the functionality is mostly the same as with EIP 1559. It's just strictly a small extension to express the fee payment and to register the data. And so there's this max fee per data gas that's added, and there is a list of hashes that refer to the commitments that then refer to the full contents of the blob. And the pretty thing here is that the data hashes, they are easily embedded into the transaction. They don't take a lot of space. They are 32 bytes long, so they fit in the EVM very nicely. Whereas these commitments, these are 48 bytes. They go into the beacon chain, and they are KCG commitments. KCG is this special commitment type, similar to what a Merkle tree does, except instead of a Merkle proof, you have an opening to prove any particular point or multiple points in this set of blob data. And this allows you to build an efficient proof for the contents of the blob when you need it in the EVM, but otherwise basically optimizes away the proof data. And this is the key part for full dank sharding, for this full fission of data availability sampling, to have this type of commitment in there. And so what this really means is that the transaction goes into the EVM. Like at first it's generalized, it's abstracted as this message, just like any other transaction. The EVM doesn't really know about transaction types. But this additional wrapper data, the commitments and the blobs, they don't go into the EVM. They leave the execution layer and they go into the consensus layer. So how does this lifecycle work, right? I'm this layer 2 user. I want to utilize the shard data. What does this mean? Well, you just use Ethereum as you would use it today. It's a lot like just sending a layer 1 transaction, except it's on layer 2. It's on a rollup. And then the rollup operator or the sequencer, they bundle the transactions. And then the transaction bundle, what really happens there is that it needs to be submitted to layer 1 to make it available for verifiers to see and like reproduce the layer 2 state. And so this bundle of transactions, it's encoded. It might be split across multiple layer 1 transactions. But really the key here is that the data is encoded into blobs, and these blobs paid for with blob transactions go into the layer 1 transaction pool. And then the beacon chain proposers can pick up on transactions from the transaction pool. They can build their execution payload. And then along with the execution payload, there's now this new addition of a blob sidecar. This is additional data that comes with the beacon block. And there's a separate syncing method to distribute the sidecar. And the beacon chain distributes the data. And then everybody on the beacon chain, they hold onto it for a certain amount of time. So they hold onto it for like 2 weeks, maybe a month, depends on the exact parameters in EIP 484. And then the execution payload stays in layer 1 with the fee payments, but then the blobs eventually get pruned from layer 1, meaning that the resource usage on layer 1 is bounded. Bounded resource usage is like this long-term goal of Ethereum, where we shouldn't always keep growing the state and growing the chain history. We want to make this sustainable. And so this is a really important feature of 484 and of sharding in general, that once you start adding a lot of shard data, that we don't rapidly increase the resource requirements of regular layer 1 nodes. And then it's for up to the layer 2 to persist data long term. And this is not at risk anymore after the proofs that secure the assets have already largely been completed. It's then up to the layer 2 community, the stakeholders of that rollup, that the now fully agreed upon layer 2 state is there for others to sync and join this layer 2 ecosystem, similar to what we do on layer 1. And so this is what it looks like in terms of the network. We have the sequencer and this transaction pool. You could think of it just this cloud of suggestions for the layer 1 proposer to build the perfect block. Then the blobs and execution payload make their way into the beacon chain. Then the other nodes on the network, they verify the fee payments and they verify the data is there, but then the data is retrieved by another layer 2 node, the layer 2 verifier, to reproduce the layer 2 state, using this data as an input to the rollup. Again, parts to talk by Calvin to learn all about how the rollup processes this data. Now, how does this work between the layer 1 consensus layer and the layer 1 execution layer? We used to have this API called the engine API, and we have the same API right now, except we are adding one method and one type. We're adding this blobs bundle so that everything that comes with the transactions can be paid for by the transactions, but it's then bundled together and separated from the regular execution payload. And so the consensus layer can retrieve the execution payload to embed in the beacon block and can retrieve the bundle of blobs, the sidecar, to then distribute to other beacon nodes for the period that the data needs to be available. So we talked about like how 484 works on layer 1. And to complete the picture, we also need to talk about how EIP 484 works on layer 2, because this data would be kind of useless if there were not all these many different rollups building ecosystems, extensions of Ethereum on top of this data. And so what it means to update layer 2, it means to update the proof so that the inputs that we now change about the layer 2 make their way through the layer 2 state transition to produce the new layer 2 output. This transition has to be proven on layer 1. And then we change the verifier code to actually pick up on this data, to process it in the first place. And we change the batch submitter to even submit the data before the verifier can pick up on it. And so it's really batch submitter first, then verifier, and then the proof shows the full transition of processing blob data, running the layer 2 state transition, and then producing the output that then is claimed or validated on layer 1. So I'll show this simplified ZK validity proof. ZK rollups, they all work a little bit different, but if you generalize them a little bit, what it looks like is that there is some form of computation on layer 1 that verifies witness data to show one state root on claim going to another claim, and the proof shows that this transition is valid. And so how this works is that we first want to prove that we have the correct data in our system. And since not every ZK rollup is built with KZG, what some will have to do is this proof of equivalence to show that the KZG commitment over the data is equivalent to the commitment that they prefer to use. Luckily, because this is a polynomial commitment, this can be done rather efficiently as part of the ZK proof in a way. And so there's this precompile that allows you to evaluate a polynomial do a single point evaluation. And this can be used to do a random evaluation, and random in a way that you can securely verify it against another evaluation in another different kind of curve or some system that the ZK rollup prefers to use. And then once you have verified the inputs, you can run your regular ZK validity proof using the same form of input that the ZK rollup is already built for, and then produce the output, or verify the output really. And then all you need to do at the very end of this is to just persist the outcome. Now, we also have optimistic rollups, and they work differently. However, we use the same precompile. So the additions to the layer 1 EVM, when we want to verify blob data for optimistic rollups or for ZK rollups, they are the same. We can have this common utility to verify a single point of blob data, except that we use the precompile slightly differently, where like an optimistic rollup, they have the notion of this pre-image oracle, and the pre-image oracle is used to access any history in the layer 1, which could include blob data. And then depending if it's a regular hash or the special KCG commitment, we use a hash function to verify the pre-image matches the claimed hash, or we use the point evaluation precompile to verify a piece of blob data at a certain position matches the commitment to the set blob data. And this extended pre-image oracle, we can plug into the existing single-step verifier. And so it doesn't matter if you're like a WASM proof system or a MIPS proof system or a RISC-V proof system. If you have this general idea about loading inputs through pre-image verification, you can plug in this new type of pre-image backed by blob data. And so this is kind of what it looks like to integrate it into the verifier. So we talked about the proof part of layer 2. We also have to modify the verifier. And then the batch submitter is really just the reverse system of the verifier. In the talk of Calvin, you have seen that there's this input stream and there's output stream. Now this is the process that takes the input stream and converts it into the output stream. In the OP stack, it's called the layer 2 derivation pipeline. And what it really does, it traverses the layer 1 chain, the chain of inputs. It retrieves the data. It processes the data. It might use a layer 2 execution engine to process the data. That's really only the retrieval that we have to adapt to this new type of data. And then the batch emitter, which does the reverse process, then it takes a layer 2 block that has been sequenced. It is going from the layer 2 block. It extracts the inputs, encodes the inputs in a batch. And then the batch needs to be encoded in layer 1 transactions. And this layer 1 transaction is published now with blob data rather than call data. Okay, so we talked about how layer 1 works, how layer 2 works. If you really want to slot them together, we need the layer 2 operator to pay for this resource of layer 1, this new type of resource. And what this requires is a new type of gas metering. Except that I wouldn't even call it metering at this point, because the EVM does all these complex computations, whereas data is just static. It's very easy to meter. We could look at the amount of data, we can translate it to the amount of data gas that's required to pay for the data. And now this data gas, it works very similar to regular gas, very similar to EIP 1559, where we burn the funds, we burn the fees, if there's an excess in usage. And then in the block header of the execution layer 1 block, we maintain a special variable that can track what kind of excess there is. In EIP 1559, we know this as the base fee. The base fee goes up if there's an excess. It goes down if there's not an excess. You could express this in many different ways. It doesn't have to be a floating point like variable that moves around. It could just be more discrete and you could say, oh, there's this much gas that's being utilized over the expected amount. And so what it looks like is that the more excess there is, the higher the price goes. And note the y-axis here, it's a logarithmic y-axis. And so exponentially, the cost goes up if there's more excess usage. And so it balances itself out. If the excess usage goes up, prices go up, and then either users are willing to continue to pay elevated prices to continue to use the target usage, or they compensate and they start using less for a little while, and then the prices go down again. And so the base fee in EIP 1559 or the excess data gas in EIP 444 help balance out the resource utilization of the chain. And so we target half, and we have a maximum capacity of twice the target, similar to EIP 1559, except now with data gas rather than EVM gas. This is how this is expressed in the EIP. It's a little bit hard to parse because the formula is different, but it has the same properties. So just at the same rate as EIP 1559, a rate of 1.125, and it goes up exponentially this way, or it goes down exponentially. This depends on the resource usage, and the limit is twice as much as the target. And the only addition that we need to maintain this state is this one field addition to the block header to track the success. Okay, things are going well so far. We've talked about how 444 works, both on layer 1 and layer 2, how the fee structure works. But if you are interested in diving deeper into this to really understand it, you should look at the specifications. This is an EIP that spans across multiple layers of Ethereum. So there are consensus specs, and then there are execution specs. The consensus specs, they're scheduled per hard fork. They're isolated per hard fork. Whereas in the execution specs in our EIP system, they are targeting just specific features of EIPs. Now, there is a new execution specs process that describes the EVM in Python. Expressing 444 there, I think, will take a little bit longer. But the specs are complete. The EIP describes the execution changes, and the consensus specs have all the consensus layer beacon chain changes. And then what would things be if there were not other specs repositories? So we talked about the state transition changes with consensus and execution. But there are also APIs that have to be extended. So there are the execution APIs to support a new transaction type. There's the engine API to pass along the blocks, the blobs between the engine and the beacon node. And then there's the beacon API, which has to be modified to fetch the blob data. This is the API that layer 2 clients, verifiers, would now start to use to pull the blobs from the beacon node into their layer 2 node. And then they can cross-verify it against the data hashes that have been registered in the transactions that they already parse as part of the regular Wallop traversal process. Now, implementing all these specs is not easy, but we're getting there. We have 5 different consensus layer teams and 5 different execution layer teams, actually more than this even, implementing the specifications and participating in testnets. So we started with just Prism and Geth as a prototype a year ago during ETH Denver. And since then, we have improved the syncing methods, improved the transaction pool, and we're still polishing various different things about the EIP. But the specs are stable, and so clients are moving forward. And now we have all clients participating on the same testnets. We have this client interoperability. And then it doesn't stop with just client modifications. Part of EIP 424 requires this new KZG commitment to really be forward compatible with the long-term sharding vision. And this vision requires a trusted setup, or this KZG ceremony output. And this thing has been running for like almost 2 months now, I believe. And also, there are about only 2 days left. So if you still want to participate, there's still a chance. This thing is hosted online, and you can use various different clients to participate. I'm showing you this server graph because it's kind of insane that so far we've had over 70,000 contributions. And when I was sharing about 44 just 2 weeks ago, I think we were at 50,000. This number is rapidly increasing. And the more contributions we have, the better, because the more we distribute this responsibility over like not refeeding all the inputs to the ceremony, and just one of the inputs has to stay like private, hidden. It's like toxic waste to secure the final output. And then this final output is used to secure the blob data effectively. And there are various fun clients. There's not just the official clients. There are also like meme clients. So there's this front end that is Dogecoin themed. I recommend just browsing around the KZG clients and to try and participate in fun new ways. And after this, like 2 months of regular participation is over, there's also a special time allocated for teams and participants to do special contributions, to mix in their randomness in different ways to create more diversity, to reduce the risk even further. But yes, like 70,000 participants, it's kind of crazy. This is like already 10 times, if not 100 times more than what most ceremonies are getting. Okay, let's talk about progress. So this EIP has been around for almost a year. And since like last year in Denver, we've achieved a lot. We've worked on prototypes, we've worked on the EIP draft, then transformed into more specs. Then there were workshops, more education, DevNet started. This is something where I really appreciate the help of Coinbase contributors and like other early folks like Terrence from Prism, who like put a lot of time into these early prototypes to show that it works, to show the viability, to explore optimizations. But now we're at the point where we're running DevNets more regularly, and the KZG ceremony is almost coming to an end. And in DevCon, we started DevNet, or shortly after DevCon, we started DevNet 3. And then earlier this year at the Interop event, there was this DevNet that really pulled in all the clients, where like you can see that it's viable to ship in a hard fork. There's this interoperability problem with many EIP changes, where not all clients always implement the same thing. But clients are agreeing on the same blob data. And with more testing, more polishing, we can ship this as part of a future layer 1 hard fork. And so currently this is scheduled for the DNAP hard fork, which is the one after the withdrawals. Right now we have various different testnets behind us. Started with version 0, the hackathon. Then there were various different devnets. And increasingly, we have been extending this from prototypes to something that's like adopting all the spec changes and the latest features as discussed during this interop testing. And the latest features really, they are the transaction type, the transaction pool hardening, and a decoupling of blobs. And once these things are finished up, then we're looking at the final stretch, the final milestone towards a production ready for it for. And then hopefully can go live with the next hard fork after the withdrawals. So DevNet 5 is coming up. This updates the transaction type primarily. This is somewhat of a breaking change. The update here is that we want to perfect the way we structure SSE transactions and get it right. If this doesn't work out, we might revert to an RLP transaction, but right now there are strong proposals for SSE transactions to shape the way we sign over transaction data in a more structured format, which will be very good for layer 2 long term to prove any data about any transaction. And then we have some network optimization, decoupling of blobs. What this really means is that the blobs and the beacon blocks are gossiped separately. And so the smaller the messages, the more effective gossip sub is at propagating the data efficiently and without duplication. So this also saves us more bandwidth. And then we have transaction pool hardening, meaning that we don't want blobs to have a negative influence on the regular EVM transaction pool. So we're trying to isolate the properties of these blob transactions as much as possible and have a really strong implementation that can handle the data. And so this likely will be like a pool-only mechanism where we avoid putting in large amount of data if we already have the data. And then there's more testing. There's always more testing. If you want to contribute, this is probably the best place to contribute. We are building more test vectors. There's work on Hive. And there are various other things to benchmark 484 to make sure it will run well on layer 1. So if this is still not enough for you, look at eip484.com. We have a question and answer section with Vitalik answering things about 484. There are various different resources you could read more about 484. And then if you want to get into contact, if you want to really contribute actively to the implementation, to like analysis of the KZG ceremony, or like other post-processing, or perhaps you just want to visualize the blob data, or maybe you want to contribute to the new block explorer that visualizes blobs. There are all these tooling efforts as well. It's not exclusively client development. During DevCon, there was a team building a block explorer, like an experimental block explorer specifically for this data. And during the EVE Online hackathon, I also hope that more teams can build cool and new interesting tools that utilize this new concept of blob data. So yes, any questions? If there's time left, we can go through some things. Otherwise, let's scale Ethereum together. I'm looking forward to everything that's being built during this hackathon. Thank you.
Amazing. Thanks, Proto. There's a lot of time left for questions, but you were surprisingly on a 44-minute mark. So I'm going to just verify this again after we jump this video. But this was actually very informative, and I think this is the only resource now that exists on the full depth of what 4844 is. So thank you so much, and this has been awesome.
Yes, my pleasure. Thank you for hosting this.
Absolutely. Take care. All right, with that, we are ready for our next talk. And for that, I'd like to invite our next speaker, Hai-Chen. Hai-Chen is going to be talking about how ZK rollups and ZK-EVMs work, especially from the context of how Scroll is designing it. And you can already saw him talk about all the prizes they're giving. You already talked about, we already saw a lot of talks around how to think about these technologies as rollups become more and more common. And we're going to go into a lot more depth here now. So without further ado, I'd like to welcome him on stage. and get started. So welcome, Chen. It's great to have you here again.
Yeah, thank you, Kartik, for the introduction, and thank you for having me here to present to all of the people in the East Global and then Scaling Ethereum event.
We're excited. So I'll let you take it from here, and all the best.
Okay, cool. Yeah, hello everyone. I'm Chen from Scroll. So today I'm going to give a introduction to the ZK ROP and then the ZK-EVM, and I'm going to dive. We'll just introduce like how the ZK-EVM is built, and then what is ZK-EVM is going to prove. So give like a little bit more insights of like how we are building the ZK-EVM from the Scroll. Okay, so first of all, like we all know, Ethereum is great because it's decentralized and secure, and it has a humongous of community and developers are building on top of that. But Ethereum also has its own problem that it's not built to be scalable. So to handle like thousands of transactions per second. So this is because of the blockchain trilemma, that one blockchain cannot achieve scalability, decentralization, and security at the same time. And we all know like decentralization means that a chain can run without any trust dependencies on a small group of centralized actors. And this is typically interpreted as to be like not trusted by any set of the nodes. And security means like you can sustain the attack from a large proportion of the nodes running the inside the networks. And the scalability just means that the blockchain can process more transactions than a single node. And we know that the Ethereum and other like the traditional blockchain, for example, Bitcoin, they all prioritize the decentralization and security, and then such that it both suffer from the scalability issues. So to take a deep, closer look at why Ethereum or like other blockchains is not scalable, it's because like we can show like this, like a diagram of this how Ethereum works. So user sends transactions to an Ethereum node, and then the transaction will then be broadcasted to a P2P networks. The proposers then will submit a block, then everyone in the network will download this block and re-execute all of the transactions inside this block to reach consensus. So that means like all of the full nodes need to do the same thing, like same computation for every blocks. And because the Ethereum is widely decentralized, so hundreds of thousands of nodes will repeatedly doing the same computation for every block. And that's why the Ethereum is not like built for scalable, because it sacrificed some like it has a lot of redundancies in computation just for being resistant and being censorship resistant, and then also being decentralized. So how does the Ethereum community plan to solve the scalability problems? So about 2.5 years ago, Vitalik posted this blog post on the forum, so about this rollup centric roadmap. So the plan is to scale the Ethereum through the rollups chains that can process more transactions on the layer 2, but having the efficient settlement and finalization on the layer 1 to scale to achieve the scalability and without sacrificing lots of the securities for that. So now let's take a look at how the ROP works in general. So here now you have two chains. The first, the layer 1 being the Ethereum, it serves as the settlement layers for any transaction happen on the layer 2s. And then the layer 2 becomes a less decentralized blockchain, so that it can process more transactions and blocks at a faster pace. And periodically, the layer 2 will batch all of transactions and send sufficient data to the layer 1 with some sort of the proof to finalize all of the transactions in this batch happen on layer 2s. So the requirement for a rollup to be a rollup is that the users can recover the latest state root on the layer 2, purely relying on the data stored in the layer 1s. And then there are two types of the rollups right now. So one is the optimistic rollup, and the other is the ZK rollup. So I'll give like first some of the intro like about what is the optimistic rollup. So the optimistic rollup is that it will just submit the transaction data to the layer 1, waiting for a period of time for the challenges. So if no one challenged like there is any invalid transaction within that batch for a certain period of time, then that batch of transaction will be considered finalized on the layer 1, and it cannot be reverted anymore. However, the drawback of this optimistic rollup approach is that the waiting period time is sufficient, is quite long. So the people need to wait for 7 days until that transaction can be considered as finalized on the layer ones. So that's why like the people will like tend to work on another type of rollup. It's called the ZK rollup. And in the ZK rollup, every time like you will not only submit the data to the layer one, but it will also accompany with a ZK proof that can be easily and cheaply verified on the layer one. And then once this proof is verified by a smart contract on the Ethereums, and then that batch of transactions can be then sync of finalized. That's how like you achieve fast finality for the ZK rollup with the ZK rollup. So, but like let's simplify the diagram a little bit. So for the ZK rollups, so basically you need to, on the layer two, you need to build a prover that's going to generate a ZK proof and then accompany with some data, and then both were submitted to the layer one for settlement and finalizations. But the problem with the ZK rollup is that it is non-trivial to build a ZK rollup system for many reasons. So first is that to generate a proof for some computations, you need to write down your program logic in the form of arithmetic circuit. And it's quite complicated and hard to being like using only the additions, multiplications, and some of the math assertions in the circuit to express your computation, your program logics. And also it requires certain overhead to handle like to generate this ZK proof for the ZK rollups. And also like even worse that different programs and different applications may have a different circuit, such that like you need to encode every application you need to write a new circuit to be able to using the ZK rollups. And even worse that there will be no composability between the different application-specific ZK rollups. How to solve this problem of this no composability with different application-specific ZK rollup is that we need to build a general purpose ZK rollup that can run any type of applications. And then one of the type is like you can, is where we are building is called ZK-EVM. What we do is trying to put the Ethereum virtual machines into a ZK circuit so that any application, any dApps that are written using the Solidity, like built on top of the Ethereum, can be run directly on the layer twos, and then using the ZK-EVM to generate the ZK proof for that any applications that deploy on the layer twos. So that's the benefit of having the ZK-EVM in the layer two and the ZK rollup, is that you can achieve the composability and it being also very developer friendly, because all the developers need to know is still the Solidity and using the same tool chains, Foundry, Hardhat, anything like you using on the layer ones, you can also using on the layer twos. But there are also some drawbacks for building the ZK-EVM. So one reason is it's very hard to build. So the Ethereum virtual machines is not built for the ZK, so it's not very ZK friendly. So you need to be very careful, and a lot of like and it's very hard to build like putting the entire Ethereum virtual machines into the ZK proof. And then due to like this incompatibility of the basic field with the finite field using in the zero knowledge proof, and also there's a lot of special opcodes like catch-hack, some bitwise operations, and also the signature verifications, the ECDSA signature verification. They are all quite special functions, like, and they need to spend a lot of effort to building the ZK circuit. And also to generate the proof for the ZK-EVM, there's quite large proving overhead for that. So that's why like initially people are more tends to building the application specific ZK rollup instead of building the ZK-EVM. So why is the ZK-EVM possible now? So there are mainly three reasons. First, we are not having better zero knowledge proof systems. We have like a lot of new primitives such as the polynomial commitments, the custom gates, lookup arguments, and the recursive proofs. All those like recent advancement in the zero knowledge proof protocols that makes the building the ZK-EVM more practically available, like viable. And the second, we have more hardware acceleration available. We have right now like the more and more like the state-of-art GPU prover algorithms, and then we also we're expecting the FPGA or ASIC, some accelerator, ZK accelerator solutions in the future that can further bring down the cost of generating a ZK proof. And the third is that we have a lot of new open source toolings and frameworks available. And also, like not to mention, like the Scroll is building the ZK-EVM in the open source communities with the Ethereum Foundation, like the PSC team from the Ethereum Foundation and other open source communities. So there's lots of tools and the resources available in the open source, so that making the ZK-EVM building like the viable and practical. So now let's dive in deep into a little bit like about ZK-EVM. So there's like a few different ZK-EVM flavors, which they all call the ZK-EVM. So first is language level compatibility with the Ethereums. So that means like you can compile some EVM friendly language like Solidity or Euro into a snark friendly VM, which differs from the EVMs. And the second is bytecode level, which you directly interpret the EVM bytecode directly inside your ZK circuit, so that you don't need to use a different compilers. You can reuse all of the same tool chains to directly use that, and then you can run on the ZK-EVM. And then the last one would be the consensus level, which is target for the full equivalence as the with the EVM using on the layer ones. That means that this level ZK-EVM can directly prove any layer one blocks. And here, like what we are building in the Scroll is that we're trying to target for a bytecode level compatible or equivalent ZK-EVM, such that like the developers can using all of the existing tools to building on top of the Scroll. Okay, now next we're going to talk more about the ZK-EVM. And first, let's focus on what the ZK-EVM trying to prove. So let's simplify the Ethereum, like the EVM, how it works. So first of all, at one time step, like T, you have like a state root trees that including all of the state account informations and also the any storage trees stored in the smart contracts. And at that time, you'll receive a new transactions and trying to do any like the transfers or executing some smart contracts. So you'll input these two as the input to the Ethereum virtual machines that are going to execute, and the output, the result will be a new world state with a different root after you apply the transactions. And then looking inside what happens inside the Ethereum virtual machines, you'll basically have like a few different modules. First, you have a state machine that's going to interpret all of the bytecodes inside your inside any smart contracts. And you have stack and a memory for any transient data keeping the memory. And also you will access to two databases. One is the bytecode database that's going to load the smart contract from that and execute them. And the second, you have a storage database that going to keep any state account information as well as like any storage like the stored in the smart contract. So let's like take one further step into looking at what happens like when you're executing the smart contract. So after you give like these two inputs, the world state and then the transaction to the Ethereum virtual machines, and then what happens that you are going to execute opcode by opcode written inside this smart contract, and it will end up with a execution trace with different steps. For example, like you will do a push and then some mstore, mload, and then you do like the load some call data from the transactions, and then execute like any specific logic from the smart contract. That will be finally ends up like modifying some data in the storage and in the state account tree. That will be generate a new state, world state. So now what ZK-EVM trying to do, like to add like the additional steps inside this, like the whole pipeline of the executions, is that the ZK-EVM is taking the specification of the Ethereum virtual machines, and then it will take also the same input data from the how the Ethereum virtual machine does is take a world state snapshot and then taking any new transactions as the input data. And then what it's going to prove is that it's going to prove this execution trace generated from the Ethereum virtual machines is correct, and it will also prove that the state root will transit from the old state root to the new state root. So to summarize a little bit, like what does Ethereum is trying to prove is like you first need to prove the execution trace generated by running the Ethereum virtual machine is correct and unique. And the second, that you need to prove the global state root to transit from the old root to the new root. Okay, so this is like some high level, like the things about what ZK-EVM is going to prove. And then let's dive a little deep into the how we build the ZK-EVM in the circuit. So remind that I just explained that the ZK-EVM is trying to prove that the execution trace is correct with like after applying certain transactions and then executing some smart contract. So that would be, the logic is quite similar to what happens inside the circuit, where the core circuit in the ZK-EVM that we are building is called EVM circuit. The EVM circuit is basically state machines mimic the state machine inside the Ethereum virtual machines. So you are also mapping all of the steps inside your execution trace into your circuit, which looks like just in this like the blue table. We're just looking like a two-dimensional matrix, and then each step will map to a slots inside the circuit as well. So like one-to-one mappings to the steps, and then one step will be corresponding to any opcodes you are executing inside the execution trace. So each step inside the circuit will having slightly different height due to the complexity of different opcodes. So for example, the multiply opcode from the EVM maybe like it's more complicated than an add opcode. So it may be taking more rows and more resources in the circuit to prove the correctness of that opcode. And then if you take a closer look at each step slot inside the circuit, you will be separated into different sections. So you'll be having the step context, keeping some contacts of like the stack pointers, the program counters, so the informations. And the second will be a case switch. Are going to switch on different opcode specific constraints. So for example, there will be like the one case for each opcode corresponding to like the two opcodes you have inside the Ethereum virtual machines. But this is basically a switch statement like you written inside any languages. And then the third section will be any opcode specific witness that are going to help you to prove the correctness of any opcode. Yeah, it's like I just explained, like for the step context, you are keeping certain informations that for this current step is. For example, which code hash are you executing? Like it decides like which contract you are executing, and then some gas like you left it in the transactions, the program counter, stack pointer, and the current state root, etc. Like there will be more informations. And then for the case switch, it will be basically a bunch of selectors corresponding to each opcodes in the Ethereum virtual machines, and also different error cases. That's also important that you need to handle. You need to prove and handle all possible errors when happen when executing the transactions. And also, we need to make sure that exactly only one case is switched on under each step. And then last one will be some opcode specific witnesses. Will be like some of the input data, for example, like the word like you're going to add together, and then the results you can go and do. And then there will be also some additional witness that are going to help you to prove the correctness of each opcode. So let's take an add opcode as an example to see what happens inside the in the ZK-EVM constraints. So first of all, you need to constrain the step context is transit correctly from the previous steps. So for example, in the current step, if I'm executing an add opcode, so the program counter, the next step program counter will be increased by 1 from the current step. And then the step pointer will shrink by 1 because the add opcode pops two words from the stack and then push 1 back to the stack. And then the gas left will be like reduced by 3 because the add opcode will consume 3 gas in the EVM. And then second, it will be a case switch. That means like only one of the case, like one of the case will be selected, which is add here. So that means like so first you need to prove each opcode will be the selector will be 0 or 1, and then finally you need to constrain like all of them sum equal to 1. And then last will be some opcode specific witness here. Is that, for example, because of this field incompatibility between the circuit and then the EVM, So the EVM word has 256 bits, but inside the circuit, you can represent a value up to 253 bits. So that's why you need to break down the those words into two parts, like with the high 128-bit and then low 128-bit values. And then so you need to do like additions. For example, you need to say like for the low 128 bits, like A low plus B low will be equal to C low plus some of the carry on like into the next high 128-bit, and then do the similar things for the high 128-bit additions here. And then further, what you need to do is you need to prove that the word A, B are correctly popped from the stack, and then the output C is correctly pushed back to the stack. So what you're going to do is you introduce an additional lookup table that help you as an auxiliary data structure to help you to prove any stack or memory operations here. So here, what you're going to do for proving the stack pop is that you just do a lookup, thinking like okay, so I'm pop up like the stack at a certain stack pointers with its read, and then that's all going to like the value you're going to pop up from the stack. And then after you do the calculation of the word C here inside the circuit, you're going to push back, push the stack back and write back to the correct address inside the lookup tables. And because this lookup tables is also constrained, it's also constructed after the executions, so that you need to have additional circuit to constrain that the lookup table is constrained correctly. So this is like some of the just high-level explanation of the building the ZK-EVM circuit. There'll be like a lot more details, but if you're interested, you can definitely look at the open source repo to dive more deep into how the code is constrained there. But just give you a high level of the architecture of the ZK-EVM. So the ZK-EVM, although we call like a circuit, but actually it constructs with a lot of sub-circuits together to function together, constrain together, such that it can be built to constrain all of the executions happen in the Ethereum virtual machine. So in the beginning for the ZK-EVM, you have the core part is the EVM circuit that serves as a state machine to constrain each opcode that happen like inside the Ethereum virtual machines. But for some of the ZK unfriendly opcodes, like the AND, OR, XOR, those bitwise operations, the exponential opcode, and then the catch-hack computations, we'll be relying on like offload those kind of computation into the lookup tables, and that will be further constrained by other circuit to help you to constrain the whole these opcodes. And then second, for any stack memory and storage operations, we'll be relying on a RAM lookup table, as I just showed before. So those like a RAM lookup table that it serves as a database that consists of all of the records of stack and memory and storage operations. So inside the EVM circuit, you don't need to reason about like the correctness of those operations, but you just find a match inside the lookup table, the database of all the records. Now, once you have a match inside those RAM lookup tables, you will consider those stack and push and pop is correctly, the memory read and write is correct inside the EVM circuit. And then you have some additional lookup tables to help you to load correct bytecode from the smart contract, and you can load certain informations from the transaction call data, and then some block metadata from the block lookup tables. So all these lookup tables will be then further constrained by some other circuits to help you to prove that those lookup tables is correctly constructed inside the circuit. And then in order to serve this to constrain, help you to write all of the lookup table circuit, you will also introduce some additional lookup tables and additional circuits. So for example, there will be some Merkle-Patricia tree circuit will be constraining any reader write to the storage and state trees. And then also there will be some transaction signature circuit, ECDSA circuit, help you to verify the transaction signature is correct. And then there will be some RP encoding for the transaction here. There will be some RP lookup table and RP circuit. And then finally, you will introduce a public input circuit that are going to connect the public input data that you uploaded with the rollup and then constrain like the certain data is correctly calculated in the whole ZK-EVM circuit. Okay, so lastly, a bit like about Scroll is that we are building the ZK-EVM with the community, like with a lot of community members. Not only like Scroll is doing that, and we also like having this design, and all of the code has been peer reviewed by the communities, where like community members from like us and from the PSA team of the Ethereum foundations, and also like other many more people like who are interested in the ZK-EVM and then contributing to the ZK-EVM repos. And if you're also interested, you can also take a look at the repo, and it will welcome you to contribute to the same repo together. And then lastly, about like our principles, like while we are building the ZK-EVM to scale the Ethereums, we still like follow our principles when building things. First, we aim to build an EVM equivalent ZK-ROP so that it can achieve the best-in-class user and developer experience. And second, we still like to keep a security-first mindset when building the layer 2s. So where like we first have the ZK-EVM and ZK-ROP protocols that can explicitly prove the correctness of any executions and transactions on the layer 2. And then we also actively having this external and internal auditings on our code base, and also being like building with the community, building like in the open, so that like all of the code can be also peer reviewed by others, not only like us building like in-house code. And third, we also believe in the decentralization matters in the layer 2 context, so which we think like it will be the key property of the blockchain to be censorship resistant, and then to be also social resistant, so that we are committed to decentralize across all different layers, including we're having a prover, decentralized prover network, and a decentralized sequencer or validator network. And then last, like I'll just talk about like we also have like a hackathon bounty program in this event. And then we will have 3 different tracks. First, we will ask you to deploy your smart contract on top of the Scroll testnet. That's a public testnet on the Gertie. And then the deployment process will be just very similar to what you do on the top of Ethereum. You only need to change RPC endpoint. And the second is that we love zero knowledge. So show us your best application building new use cases that leverages the power of zero knowledge proofs. And the third track is that we want to see the developers and the dApps taking advantage of the cheap gas fees and a faster block time on the layer 2s. And you can benefit from the layer 2 scaling property and a faster finality with the ZK-ROPs. And hope you enjoy like the hacking on top of the Scroll testnet. And for more information, you can also check out this website. Okay, that's all about like my talk. And thank you everyone for listening to the talk. I can take any questions from the audience.
That was awesome. That was such a good overview on how everything is set up. We don't have enough time for questions because we want to make sure that we can get to the next talk. There's a time constraint on the other end, but I'd love to kind of maybe just ask you one little thing as we get the next speaker set up, which is if you have a wish list of what you would like people to build on Scroll or just on a ZK-EVM. Is there something that you've been really wanting to see that you haven't seen yet, or you think there's something there that people should try? What's on your wish list?
Yeah, that's a good question. So I think the wish list, like we are seeing like that. I think like the ZK-EVM is building like for general purpose. So any type of applications, any like innovative like the applications can be also like built on top of that of the Scroll ZK-EVM layer 2s. But like I think like some interesting thing would be you can think of like any ZK applications that'd be interesting, like privacy or like any private votings or any like this like social application like identities, like those applications I think would be innovate like the more easily on the Scroll.
So that's an interesting point. So maybe I also misunderstood. How would private voting work here? Is it just the fact that you don't get to see the weights, or like where's the privacy coming from in this example?
Yeah, so like to just clarify, like actually the ZK-ROP usually doesn't provide privacy by default. So there's like it's more for the scaling and the compression of the transaction happen. But for like any private applications, you're probably like having the private shielded pool, so that anyone you can hide the identity of like the voters, so that you don't need to reveal your vote, but you can still verify that someone in the pool in the DAO like voted like and only you can only vote once.
So existence checks on like making sure that nobody's abusing it and
yes.
having that information be. private.
Yeah.
That's awesome.
Yeah.
Well, thank you so much. And with that, we are ready for our next talk. So go hack on Scroll, and we'll see what people build.
All right. Thank you. Thank you, Patrick.
Up next, I want to introduce our last speaker for today, which is John Cole from Hyperlane. And, John's going to talk about, now with all the rollups that we have, whether it's ZK or optimistic or anything else around modularity, how do we make sure they all work nicely with each other? And that's where multi-chain world comes in. We're understanding what's possible, what's not possible. How do you think about making what should be possible is going to be important. So for this last talk for this summit, I'd like to welcome John here with us and have him get started. Hey, John. You are muted. There we go.
Terrible start for the day.
We can edit this out.
Good to see you, Kartik. Thanks for having me. I'm going to start by sharing my screen here, and we'll get right into it.
Wonderful. And we'll get that loaded up as soon as we see it on our end.
All right. So let's go here. Okay. So what are we going to talk about today? All right. Kartik just told you that we have a multi-chain future ahead of us, and we're going to need to figure out how to deal with it. It means really a lot of things, right? So this talk today, it's titled Connecting Our Multi-Chain Future. So in this talk, we're going to cover the current state of blockchains, the need that stems from that current state as it pertains to interoperability. Then we're going to touch about how all of that relates to the scalability of blockchains, which, of course, and in particular, means the modular blockchain thesis. And then we're going to finish the call with this little thing that we're doing here that we call the Interchain Highway. And so that's why you see that little subtitle of the Interchain Highway. So this is, if you're curious, you want to know what it is, well, this is what Stable Diffusion thinks it is. And I kind of like this little impressionist style that it gave it. But let's get right into it. So the current state of blockchains, as I like to say with my dad joke style, the state of state. So we have these amazing internet computers, and they're creating loads of valuable state. But they're isolated. They can't connect. Everyone here knows this, right? Everyone who is really sat throughout the day and is going to participate in the scaling hack, like this is really not news to you. You realize that the valuable state that exists and is created on one chain, by and large, is not easily accessed by another, even if we're talking about a roll-up, and certainly if we're talking about a roll-up on a roll-up, as we will get into later today. There's been this expansion now into a multi-chain environment, which is most often it's meant deploying your app on multiple chains. And effectively, this has resulted in creating multiple instances of your app on those chains, right? Definitionally, if state can't be easily accessed between chains, as a developer building on a single chain, you really can only access and serve users that exist on those chains. And that pertains obviously to every bit of state that exists there. This is really sad because what does it mean? It means that if you now want to expand to another environment, right? You were let's say you launch as an app on Arbitrum and you're like, whoa, I want to expand to Optimism as well for whatever reason. Maybe you think that those are distinct audiences. Well, your next deployment does not benefit from your existing one. So now we're expanding actually creates another form of fragmentation between these blockchain environments. It's as I said, it's quite sad. Now, worse yet, we're transitioning into a world where there's not only going to be more chains, and deploying your own chain is going to be easier. And bear with me today. I know this might not be acceptable nomenclature, but I'm going to use the term chain as a blanket term to include what would be an alternative layer one, what would be more familiar as a rollup, whether it takes the form of an optimistic rollup and a ZK rollup. And certainly when we need to have those distinctions, we're going to get into them specifically. And thirdly, I'm going to, again, treat something like a Cosmos app chain simply as a chain. So when I say chain, don't get hung up on the notion that it's just a layer one. It is a blanket term for any one of those three. So again, we're moving towards this world becoming ever more popular through the realization of the modular blockchain thesis that not only is deploying your own chain more common, it is also made easier because there are many more of these toolkits. But what then, right? You deploy your own chain, your own environment, and effectively you've sprouted out a new planet in a solar system, a new island in the ocean. If it's a rollup for, say, and if it's an Ethereum-based rollup, you have one main line into the main economic hub, right, into the main continent, to call it like, into the main planet in that star system. But that's all you get. What about the other planets in that star system, the other rollups? What about the other islands on any island chain? How do you connect to them? What are the trade routes that you can access, right? And so that is where we start getting into some problems. Lastly, as we analyze kind of the current state, we have to talk about just how many infrastructure interactions we have as users in crypto. In fact, a new user almost always has their first interaction with an infrastructure before they ever reach an application. You know, this is something that whenever you take a step back, you realize this is certainly not the way. Recently, a good friend was talking about their experience onboarding a close friend who had never been into crypto, but was interested in collecting a POAP. That POAP was on Gnosis. They tell their friend to download the wallet of their choice. The friend downloads Rainbow, finding it to be a very acceptable and easy to use mobile wallet. Then they realize, oh, Gnosis is not supported by. So now my friend has to onboard their friend to MetaMask on a desktop. They have to move the ETH that was purchased in the first wallet. They didn't want to expose the private keys, so he tries to onboard them to that. And now they're already 30 minutes into it. This person being onboarded still has not reached this final application, collecting that POAP that they wanted to. They realize they have to enter the RPC for Gnosis, and very cumbersome. They can't find the RPC address, so they go into the Gnosis docs and they get there. Long story short, they spend about 90 minutes for him. He has to explain to his friend, and that is only after all of that work, dealing with so many parts of infrastructure, did the new onboardee into crypto get actually exposed to the app. No one here probably thinks that that's acceptable, right? There's no way that that we can work with that. So if this isn't the end state, right? Like, what is, right? You know, how do we get there? Well, how do we get to this point where like we're serving people a lot better? We know that whenever we do get this demand, we have really big scaling woes. And obviously this event that we're all embarking on in Scaling Ethereum is deeply related to that. We're going to try and find ways to do this more acceptably. And so these internet computers of ours, if there's one thing we know about, like we know how they work, right? We know that they work by making digital resources more scarce than they are otherwise. And so we know that whenever demand increases, unless the supply of these resources changes, we're going to have a rough situation. We're going to run into this situation that I'm sure everyone on the line today has run into, where you just realize just how high that gas cost is. And how do we solve that? So we're going to talk about this today, and to solve this, we're going to talk about the combination of interoperability, modular blockchains, and a few other things that will come up. So what does an acceptable like multi-chain future look like? Well, it has to be more. If it has to be more acceptable, then we need to find a solution to that demand problem. We don't want the gas to be too damn high all the time, right? Should we ever talk about a future where demand doesn't increase? No, we shouldn't talk about it, because everyone here is very passionate about the industry, and a future where demand doesn't increase is just not that interesting, because it means we can all go home. We did not fulfill our goals of crypto being a solution to global problems. So hard stop, we're not even going to talk about it. The only way to cater this demand is by creating more supply for it, and that supply can take many forms. There will be a spectrum of chains. On one end of the spectrum, I don't think, certainly I don't, and I'm sure most people here don't feel this way, but one end of that spectrum can look like very heterogeneous environments and very monolithic chains. They might take the form of move chains like Sui and Aptos, and certainly the EVM will be a part of it, and maybe the Solana, the C-level VM will be a part of it. And on the other edge of the spectrum, we have a completely homogeneous environment. It's all EVM based. And then we just have many, many, many rollups stemming from this the singular hub. That hub can be the Cosmos hub with the SDK and IBC. It could be Ethereum with many Ethereum based rollups. Personally, I'm inclined to think that we'll end up somewhere closer to the hub version, but not completely homogeneous. So this is really what we talk about when it comes to the modular blockchain thesis. A very large amount of rollups and app chains and whatever you want to define them stemming from these hubs. Beyond that, what does an acceptable future look like? We're going to have all these chains where they're going to have to be connected. Applications are going to have to be connected. How do we prevent an experience like the one in that not so great story I just shared about a person trying to onboard into crypto for the first time to redeem a damn POAP? Apps are going to have to be connected, but if apps are connected, it's going to mean that chains are going to have to be connected. How can we get there? And before we get that, let's talk a little bit about the eras and current history of interoperability. So before we got to where we are today, which is we have some form of acceptable interoperability, majority of it is very user-centric. It's still users bridging assets. It's still users dealing with infrastructure. We had the first instantiation. That was what we call here defined rule set interoperability. One thing to note, you see a timeline here. The timeline is a bit misleading. Notice there are no end dates for any of these. This is because all of these eras are playing out simultaneously. So maybe a better title for this is not eras of interoperability, rather modes of interoperability, because these are all distinct in their form of operation, but again, all of them playing out at the same time, and it's not clear that these will remain independent and not coagulate in some form or merge in some form as we move into the future. So early on, around 2015, 2016, we have this notion of defined rule set interoperability. This is most commonly observed in Cosmos and IBC, in Polkadot and XCMP. Really what it is, it's interoperability within a set structure, and it's the same notion of horizontal scaling, where instead of saying like, hey, I'm going to have one computer that can process everything, I'm going to have many little computers, and they can have some logic about how they can share things between them, and they will handle all the processing. So the dominant form of expression here are certainly but app chains is the right way to, some people refer to them as app chains. I like referring to them as app chains. That's the Cosmos parlance, and the Polkadot world known as parachains. Some distinct differences between Polkadot and Cosmos and IBC there, but this is the common way that these are expressed in. And as we talk about each one of these modes, we'll probably spend some time talking about how exactly it's working today. And so today there are dozens of Cosmos chains. IBC transaction volume is quite high. Now, not every chain has a very active IBC channel to communicate amongst the other chains that it can communicate with, right? Like if you look at the network graph IBC connected chains. There's a lot of concentration there, but there's still certainly a lot of activity. Similarly, there are many more Polkadot parachains today, more than you'd expected would have existed certainly 8 years ago. And this category of defined rule set interoperability, while you are limited to interoperability only within that set structure and no strong form of communication with chains that don't fit that structure, it's certainly an acceptable mode of doing things and one that's going to continue to see more activity. As time progressed, there was more active participation in crypto, more types of users, and we went into what I like to call asset-centric interoperability. This was interoperability that focused on giving users the ability to move assets between different blockchains where the structure of the underlying chain was far less important. In fact, it really is not. It's only important for the operator of that interoperability service. From the user's perspective, it is entirely unimportant. Bridges are the most common expression of this, right? If some of these bridges take the form of the canonical or native bridges that we see for rollups, but certainly bridges like Wormhole, like Synapse, these are the dominant form of expression for this mode of interoperability. And truly, there's been billions that have been transacted via bridges, again, in the form of asset-centric interoperability. There's also been some issues. I want to say that as of today, at least 5 of the 10 largest security incidents in the history of the industry all relate to the category of interoperability. Now, is it because this category is inherently unsafe, or because this mode of asset-centric interoperability is inherently unsafe? That's debatable. I'm certainly biased, but I would argue that that's not the case. And it's just that software with super high stakes in an adversarial environment as the permissionless internet computers that we work with, it is very dangerous. And so incidents are going to happen. And finally, there is this last mode of interoperability. It's very, very new. There's not that much to say about it that isn't speculative, and that is app-centric interoperability. Now, if there's one thing that's very common between the two modes we observed in the beginning, at least in their operation until this point in time, is where does the burden of interoperability lie? There is an operator that provides the service, but who performs the action? In both of these, it's the user. It's the user having to move around an asset. And if you want to think about this in non-crypto terms, having to move your funds from Ethereum to Optimism, having to move your funds from Ethereum to Osmosis when you want to transact there, that has a little bit of the feel of, I really want to purchase something on Amazon today. So how about I load my balance and I transfer it from my bank account, say with Bank of America, and I load up some bucks into Amazon. I get some Bezos bucks as my balance. And that is quite strange, right? You probably wouldn't want to do that. There are not that many instances where common internet products that we use ask us to behave in that way. But this is where we are in crypto. So the key difference between these two modes in app-centric interoperability is this notion of separating or moving the place of the burden of interoperability. Primarily, it's about moving it from the user's hands to the application, so that now we bake in a layer of abstraction such that apps that are built in this way are now handling that transfer on your behalf. Similarly to, we don't know the logic of the credit card or the payment network when we get charged on an e-commerce site like Amazon, but it moves the funds on our behalf, and that seems fine. It certainly contributes to a simpler user experience. The dominant form of expression here is interchain application. But what really is an interchain application? Simply put, it's an application that should be through some means connected by some interoperability tool, something that can communicate easily between the different internet computers that it exists on. We believe that that'll be the dominant form of expression, but it's still really early. It's still not clear that this will be the case. What does it even mean to be connected by some interoperability platform? Like, what does that mean for us, like from a blockchain perspective? So for that, now we're going to step in to talk a little bit about flavors of interoperability. And by and large, they come in two main ones. You either get native verification or you get external verification. What does native means? Native means you are leveraging the consensus mechanism of the two or more chains that are connecting. And most importantly, it means there are no more trust assumptions introduced into your action beyond this idea of, I'm already trusting, Ethereum, which I'm used to dealing with. And let's say in our example now, you want to go to Osmosis. I'm trusting Osmosis, and that's all I'm okay with. And so really, native verification is the ideal method because it only inherits the security risks of the two chains that are connected. Now, why refer to it as the ideal state? That kind of makes it sound like it's not easily achievable. Well, sure as shit it's not. Sorry for my language. It is not easily attainable. Unfortunately, it is by far the most expensive and most resource costly method of verification. In fact, in systems that were not designed from the ground up to be able to replicate the consensus of external chains within them, it is just incredibly expensive. And for this reason, it works the best, and perhaps without external tools, really the only place where it works well are within these defined rule set systems. So insofar as IBC is concerned, IBC gives you a form of native verification. Excuse me. Now, should you be super discouraged? Not yet. There are things that'll help us reduce the costs of native verification that will allow native verification to be more feasible for environments that weren't built for native verification interoperability. Most promising along this front is certainly zero-knowledge proofs as a way to replicate the consensus of the chain that you are connecting with the chain that you are, to replicate the consensus of the two chains amongst each other in such a way that now having a interchain state transition is much more easily done without having to introduce a new trust assumption. But unfortunately, it's going to take some time, right? There are great advancements. You've seen stuff with ZK Bridge, that recent paper, and there are great advancements in the field of hardware acceleration for provers. And so I'm quite optimistic that within the next few years, we'll start seeing the inklings of zero-knowledge proofs and increasing the prevalence of native verification interoperability, something that is especially useful for the modular blockchain thesis and the future of Ethereum scalability. The other mode is external verification. Well, easy words to say, right? If the previous mode did not introduce any new trust assumptions, and this is the mode aside from it or opposite from it, well, you guessed it, it does introduce a new trust assumption. So external verification means that in between the two chains that you're connecting, now you bring in a third party and you rely on that third party. If you spend a lot of time looking at or trying to solve the Oracle problem or just dealing with the Oracle problem, you are intimately familiar with this. In fact, I don't feel incorrect in saying that external verification interoperability really is just another manifestation of the Oracle problem, and solutions to it often take the form of either fully fledged Oracle solutions or narrowly scoped or narrowly defined Oracle systems. external verification takes many forms, has many different configurations. The easiest and most common looks like a multisig. If you were unlucky enough to be involved in the Ronin Bridge incident, you might be more intimately familiar with this configuration. But many times it just takes on a multisig, meaning that whatever state we're replicating between the chains, the ultimate arbiter of that is decided by a key. We used to have actually interoperability systems that did not even use a multisig and were a single key. Thankfully, we've advanced far past that, and that is no longer the case. But that is a very, very popular mode, simply because it simplifies the operation, but it obviously introduces predictable and obvious attack vectors. Another configuration is proof of stake, where you can kind of enhance that multisig with some type of economic risk, meaning where these third parties that are being introduced as external verifiers now have economic risk. Now they have a real reason to not lie about what they're doing. But importantly, unlike the proof of a stake that you're familiar with from Ethereum, where ultimately a validator cannot change your balance. A validator can lie about a certain state transition, but they cannot take away your balance. In Oracle systems, you are totally beholden to what the external verifier says is the state of the world. If the external verifier says that the sky is red for all you know on that destination. And this is why proof of stake systems, when it comes to interoperability, they are completely different. They are in many ways they're similar, but where it's most important, when it comes to the key risks to the system, they are quite different than what you're used to when it comes to proof of stake simply for blockchain consensus. In another configuration, one that I'd like to hope is growing in popularity, is the optimistic construction. Again, different from optimistic rollups, but similar enough to where you can use it as a mental model. You bake some amount of time, a certain challenge window, between when some state transition is initiated on chain A and that being replicated on chain B. And within that time, watchers can observe the transition. If they find anything malicious, they can submit a fraud proof and prevent it. And last, there are configurations that will involve different forms of advanced cryptography. These can involve threshold signatures, multi-party compute, and we unfortunately won't have enough time to get into those. And there's who knows what other configurations can hold, but I can tell you that there's going to be more of them. So we've done a half-decent job of covering the history of interoperability. But now I told you we're going to talk a little bit about the modular blockchain thesis and how it relates to scaling crypto. So look, we all know with the modular blockchain thesis, we're going to have thousands of rollups and they're going to fix scalability, right? And they have to, obviously. But what does it really mean? What does it really mean for us to have all this state on Ethereum, and now we want to access it, and we have all this demand, and so we need to be able to access block space in a more refined, more targeted, perhaps even less generalized mode, such that we're not paying 500 GUI on 200,000 gas transactions on the regular, as was not uncommon during periods of high demand, as we saw in 2021. So what's it going to mean in practice? Right, we're going to have all these hubs. Right, we're going to have talked a bit about this a little bit earlier. We're going to have Ethereum as a main roll-up hub, and we're already seeing this materialize. Earlier in the day, you heard Kelvin from Optimism talk about roll-ups, and Optimism has done amazing work with the OP stack. Coinbase already took it upon themselves to extend the OP stack and launch their first, really launched the first widespread roll-up built with the OP stack. This is just the first example of this, but really do think we're going to see dozens of these, if not hundreds. Celestia, with its work on data availability, Celestia rollups will become far and wide. There are already several dozen Celestia rollups being built, and those will seek data availability either from Celestia, maybe from Eigenlayer, Lord knows somewhere. Point remains, we're going to have lots of rollups, whether it's all the app chains that already exist in the Cosmos world. These are not exactly rollups since they don't separate execution as much as your standard rollup does, but for our purposes, certainly okay to think about them. The key point to take away from it, so we're going to have these hubs, and the lowest level hubs will look like Ethereum, Celestia, Cosmos. A slightly higher level hub can look something like Optimism in the OP stack. It can look something like Base. It can look like perhaps Eclipse, which is creating a toolkit to make Celestia rollups more widespread. All of these hubs from them are going to emanate so many rollups. But how do those rollups talk to each other? How do they cross between hubs, right? We talked about the future that is acceptable to us. A scalable future needs to be a many rollup future, but how is that square away with the experience? How are we going to avoid having so many infrastructure interactions whenever we want to move between these rollups and communicate between them? And that's where interoperability comes in once again. The modular blockchain thesis needs permissionless interoperability. If everyone who wants to is going to be able to spin up a rollup on demand, if apps are going to be expressed as individual rollups, if there are going to be generalized rollups becoming a hotbed for more accessible and cheaper computation, how do we communicate between them? Are we really going to wait the 7-day challenge period going back in between them? Obviously not. No one seems to think that. But the thing that gets not enough attention is inter-rollup interoperability and interoperability across rollup hubs. And to that end, interoperability must be permissionless, but it never is. So I promised you we'll tell you a little bit about Hyperlane. So Hyperlane is the first permissionless interoperability layer. Unlike other solutions in the blockchain space, it's not another blockchain to solve blockchain problems. It's a network of networks, a network between blockchains. In that interchain highway that we talked about before, it's the path between them. So it's our effort to create the safest, fastest, and most accessible way to traverse the empty space between blockchains. And most importantly, as that space gets filled with new, smaller chains that look like rollups, look like app chains, look like app-specific rollups even, anyone has the ability to deploy Hyperlane on those and communicate with any other network that already has Hyperlane on it. So we're running out of time, but high level, how does it work? Hyperlane is deployed on any environments that want to be communicated between them. So if you use the OP stack to create your rollup, you deploy Hyperlane on it as soon as you're done creating the rollup. And now you put a mailbox on it. That's what it means to deploy Hyperlane. Then you or anyone can run a relayer. The relayer, once again, totally permissionless role, and contracts send messages to the mailbox, this contract that does exactly what it sounds like, and relayers sit in between different chains and different mailboxes, observing the mailboxes, and then they submit the Merkle the Merkle root that contains your message and delivers it to its destination. This is what we believe the best way to offer permissionless interoperability, and truly the only way that interoperability can scale to a world of modular blockchains, which we know is the best way to scale Ethereum. So it took a bit too long, ran out of time, but that in general is is our high-level talk about this today. If you'd like to learn more, you can find me on Twitter at Pale Nimbus, or you can reach out to hyperlane.xyz. You can find us on our Discord. We'd be happy to talk to you all about it. And we will be sponsoring the Scaling Ethereum Hackathon, as we do with pretty much every ETH Global event. We are large supporters and big fans of ETH Global. So we'll be here for you.
Amazing. Thanks, John. This was super informative. I feel like we got to do a part 2 here to actually dig into how Hyperlane specifically can help here with all these things. And this has been amazing, and a pretty awesome start to the summit. So we get to really see what people can do with optimistic rollups, ZK-EVMs, and cross-chain applications.
Thank you so much. I'll happily do a part 2.
Well, we'll make it happen. Even if you don't want to, you'll do a part 2. This is good stuff. We need to have this information be out there and available for everybody to grasp. Well, thank you so much. And let's wrap up today's summit. So those were our amazing talks talking about how optimistic rollups work, why you should be excited about 4844, how Coinbase's base OP chain will change and bring in millions more people into the space, and what is the best way to think about interoperability in the Web3 ecosystem. This is just a preview of what the next few weeks are about. We're going to go a lot more deeper into all the things around rollups, whether they're ZK or optimistic, MEV, new updates around those, and a few exciting launches for different products that are happening all as part of this event. So with that, I want to thank all of you for taking the time to be with us for the last few hours. And to all the hackers, happy hacking. We'll see all of you on Discord. There's a few more workshops after this that are happening. So we'll see you in those calls and learning about all the other protocols that you get to use and make your life a lot more easier. So see everybody. And with that, enjoy some lo-fi beats. And signing off from ETH Global, it's me. We'll see you on Discord. Take care, everybody.